Hey, so I am like beyond disturbed. Oh, there we go. All right. So I don't know. Um, yeah, I am disturbed though. So at which point you all log in, if you show up, appreciate you. I am so mad, but that's okay. I wanted to go on 3 devices today. Not gonna be able to do it. Hey. So if people are coming in, when they come in, when you come in, thoroughly appreciate that. We are going. I'm going today, and I'm so disturbed. Um, I'm so disturbed. I did all this work to try to create a good space, you know. Anyway, so nobody's here yet, so it's all good. So I'm still in prep mode. This is about to roll for a little while. I'm trying to make sure you can see my board. And then since nobody's here, it's all good. And then I will get to working. And then hopefully I will be able to download this to my something later. Maybe not. Maybe I'll just have to do it all again. It's all good. Okay, that's good. That's good. Oh, beautiful. Okay, here we are. So now, I know that nobody's here, and I don't know if anybody's going to join me, but hopefully, I haven't checked the volume. I hope you can hear me. It says live. All right, so my name is Miss Logan, and I am recording in a space that's too small for me right now, and I need some things. So I'm a former math teacher, and my name is Miss Logan, and welcome to Miss Logan's class. So this will hopefully be uploaded to my YouTube channel. That I'm trying to build a math channel for all students, and I have students of color in mind, and I'm starting with myself. And I know some really, really amazing educators, and I intend to bring them on at which point I can and afford to. So there's just some things that I need right now. And school is about to start. So since school is about to start and I'm building this for students, and I want it to be on IG, but IG won't let me go live. I want it to be on YouTube, but I need 24 hours to get onto YouTube. So I'm so disturbed. But what is happening? Boom. So 3D did not happen. I'm so disturbed. Wow. So I'm going to cross that out. I am on Facebook only. And I'm going to have to, I couldn't go live on any of my other social platforms. If you can see my board, then I know that you can see me. And I really, really hope that you can hear me. And if not, you can see me. Hey, I'm about to go in. And hopefully I can take this and cut it and upload it to my YouTube. If not, then hopefully this gets shared with students because I want it to be on IG. That's where I'm going to communicate with you most often. So for any students who happen to check in, I know you are like, I don't even want to talk about math. I feel you. But this is I'm front loading. There's some standards that I've looked at the curriculum for algebra. I've looked at the curriculum for geometry, and there are some spaces that I feel students could benefit from front loading, like actually looking into this information prior to the course. So that's what we're doing. I'm going to teach those things that I know students need to know based upon my years of experience. Just a little bit about who I am and why I'm here. So this is where the other places you can find me just for information, and then everything that you need to know. And if you would like to help, because again, markers, like I had to, just little stuff. I'd love a projector because the end of course tests use graphing calculators, and I want to show you, like, I don't believe in, hey, you should just know how to use that tool. I'm going to show you how to use it. So when you're on the assessment, it's not foreign. You're going to be really, really knowledgeable. So that's why I need a new computer. I need at least space to a classroom that has a projector. So if I don't have to, create my own space. And I'm on a struggle bus. I'm out of practice. I haven't taught in 2 years. It hasn't been a long time. It's just been about 1.5 years, 2 years. So I will get stronger in this process. So if you join me, again, I don't know who's on. I can't be behind the camera and in front of the camera, and I'm running a marathon. So I'm going to try to make it fun for you. If you join, hey, if you know any students who are going into algebra or geometry, so I'm gonna keep repeating this because that's what I'm doing. I'm doing algebra and geometry. All of my technology decided to act up, so I couldn't put proper titles or anything. And I am fundraising. $1 will help. If 1,000 people give me $1, that's $1,000. Then I can start building and keep building. So I am building. I'm gonna upload this from my phone. I've been uploading everything from my phone. Yay, iPhone. Not no hate to Samsung. I just prefer iPhone. I'm just saying, that's just my preference. Actually like Samsung too. I'm just used to iPhone at this point. So anyway, all that to say, this is where you can find me. Everything is going to be branded Miss Logan's Class. I'm on TikTok as well. All announcements though for the class, for what I'm posting, subscribe for when I'm uploading. But just as far as what's on there, there's a live link so you'll know what, and it's kid friendly, it's student friendly. What is a variable? We're going to talk about that today. And I'm not going to give official definitions. I'm going to teach you the way I teach my students. Not that my definitions are wrong and not mathematically correct, but just we run in a marathon. So I'm going meat and potatoes. Like, what do you need to know? And I'm going to teach you, as I do the examples, what I need to explain, I will explain in real time, if that makes sense. So until it's relevant, it's not. And then when it's relevant, I'll explain it. That's not how I'll do lessons. My mini lessons will be different, but this is a problem set day. This is a day where I'm just covering things that I know that there were gaps in the instruction when I taught 9th grade. There were gaps in the instruction when I taught 10th grade. So what are things that all students need to know if they're sitting in these courses? Even 8th graders. Like, this would be beneficial for 8th graders as well, because that's the standard group that supports the 9th and 10th grade. So if it's not caught in 8th grade, then we're going to struggle in the 9th grade. And that's what I saw. Because I taught in an alternative education setting twice. Well, no, I taught twice. Because I taught 8th period at some point in Clayton County. So I taught Algebra 2. Do not want to teach Algebra 2. Again, I know some people really, really, really better than me in the algebra arena, and I would like to call them. Geometry is my best. Even though I failed it in college, I didn't fail it. I'm lying. I didn't fail it. I'm trying not to lie. I'm trying to focus on honesty. I withdrew, and I never told my mom until now. She knows now if she catches this. But anyway, so I withdrew because the teacher was terrible. Oh my God, he was horrible. And everybody failed, and he was tenured, so it didn't matter. And so he didn't care about failing students, and he didn't explain well. So no, I'm not gonna sit in this class and just fail. I'm cool on that. So we withdrew from that course, and then in high school, my teacher just wasn't good, and so I got an A because I did what she asked, but did I learn the concepts? No. I didn't actually learn it until I had to teach it, and I was one day ahead of my students, like one. And luckily, I had some really smart SC baby. I went to Spelman College. I had some really smart friends, and so I would call them like, yo, I don't know how to solve this problem. And when the students would ask on the DAB, like, you know what, that is an amazing question. I want you to think about that, and tomorrow we're going to address that. So math is hard. That's why I'm here. You're not necessarily going to love what I asked you to do, because I am going to ask you to copy the notes. I'm going to ask you to take the notes. This is how you get it into your brain. Math is not a spectator sport, but if you just want to watch today, that's cool. Because I'm going to be going fast, and I'm going to try not to talk super fast, but I am on my coffee, and I intend to just use the bathroom, grab a snack, and keep it moving, because I have an agenda of what I want to go through, and I'm going to try to get there. So that's that. That's that. And hey, Ethan! I saw you on TikTok. Welcome. Share the link. Love you. Anyway, so we are here because when I taught math, my students had gaps. It wasn't them, and they had been made to feel like they were the problem, and they weren't. I have a degree in this, and I had to struggle for it. So I'm not going to expect my students to know math in a way that I didn't. I had to learn it, and I had some really good teachers, and many of those teachers that really, really, like, struck a chord, looked like me. And the greatest, Dr. Olubumo Spellman, and Dr. Bowers, wow, Miss Stapleton High School. Miss Stapleton explained, I took trigonometry from her, and she was like, you should have been in calculus. And she was right. I was lazy. And I'm not anymore. So, well, you know, we all struggle, but I'm not. So, moving on. We're here because I'm building a channel, and I want to be a voice to help math education improve. I have some more ideas, but I'll talk about that later. What's today's flow? We're gonna do some work, and we're gonna tell us, and I'm gonna tell a story. So I don't like t-shirts, but everywhere you go, they give you t-shirts. Well, okay, I like to cut up t-shirts. So what I'm gonna do is I have a basket of t-shirts. Here we go, boom. So this is the t-shirts that I intend to go through, and I'm gonna change shirts as I change problems. I have listed on this channel what we're gonna talk about. So we're gonna be here for a while. So by all means, I mean, I already know, you're gonna do what you do. People. So you're gonna log on, log off, share, nod, laugh, talk, who is she, all of the above. It's cool. This is for students. So if you know somebody who need help with math, then just please tell them who I am. That's what this is here for. This is also to build the content on the channel, because I'm not as broad as the other math libraries at this point. So I'm building from the ground up, and what I intend to do and what I am doing, because I've reached out to several individuals for curriculum materials, is I'm going to present the materials as the students are getting it. So it is my hope that somebody's going to give me the 2 weeks, and I've spoken to somebody who said they will, the first 2 weeks of school. So as you're getting the instruction from the teachers, I'm going to be feeding you videos on my line. So again, please subscribe if you're in Algebra 1 or will be in Algebra 1, will be in Geometry. I expect to do 8th grade standards too, because I see the gap in instruction, and I know that that's going to help 9th grade and 10th grade, because again, geometry is not algebra, no, but it is applied through algebra. So geometry is very theoretical, postulates, theorems, rules, things that you have to memorize, but everything is applied with algebra. So if you don't know algebra, geometry is hard. So even if you love the shapes and you understand the concepts, if you don't know algebra, geometry is hard. So that's why we're starting with the algebraic concepts that match in both. So these are just things you're going to need to know. And I intend to get through them all. It's only 10:30. We used to do Saturday prep, so I can do 2 hours strong. That's my goal. But if we go longer, we go longer. I got food, I got water, let's go. Okay, so what's really going on? Like I told you, I'm building a math channel. When I taught, 95% of my students passed the statewide assessment. When I led a group of teachers in the professional learning community, and we created, but I couldn't do the work. I was the leader of the building. So all I did was help them implement the things that they did, built on their strengths. And then these are the things that I did in test prep. And student achievement in math increased by 25%. So I speak math. And so I'm here because I speak math. And there are some people who connect with my voice when I speak math. And so that's what we're going to do. And I'm going to just make sure that I have every concept for algebra and geometry. That's my personal goal. That Algebra 1 and Geometry, I teach everything that, just so you can hear it in my voice. But like I said, I know an algebra teacher that's better than me. And that says a lot. If I give her those props, and I do. And I'm going to call her in, because if she's willing, I would like her to come and teach algebra, because she's better. Algebra 1 and Algebra 2, because she's much better than me. Anyway, so let the games begin. So as far as my link tree, that's where if you want to donate, I would appreciate, because I really do need so much to get this going. You're here because I got all this going on. So it's not like I can't make things happen, but I need a new computer. I need a better board. You see the struggle? So I want to use my red marker, but I ain't got to go through all of this. And I'm not going to go through all this. So we'll be using everything but red right now, because that's too much. We're going to start with the story when I pick, and I'm picking the shirts at random. So I taught at Forest Park High School, FP baby, in Clayco, Georgia. Yes, them is my babies. I taught, I was an instructional coach, math instructional coach for the teachers. So I was mini leadership in that building. Love my FP baby. So there's a shirt in there, and I was going to like just fangirl on Forest Park, and I was like, nah, because I got a lot of videos to produce, and I'm going to do that. So we are not going to do that. I have them in there. I also taught at Westlake High School, and I taught at Whitlock Flexible Learning Center. So I've had 3 rounds of teachings in 2 different states. That's Georgia and South Carolina. So that's where those standards are going to be out there. That's what I'm focusing on. It should help everyone in as far as United States in the curriculum and how it rolls out, because I'm not doing it like, hey, here is the current curriculum. I'm just teaching the standards, and then I'm going to align them the way I want later. But I'm just doing it now so students can get help now. All right, so first, picking randomly. So, Spelman College is my first, no, okay, well, not my first alma mater. Spelman College is my first college alma mater. I got my bachelor's from Spelman, mathematics, SC. Again, Dr. Olabumo gave me a D+ in a senior level course. I was like, you just failed me. But no, I earned it. But she's amazing. She's the one who taught me how to write a proof. She's the reason why I passed my leader test. And, not leader test, teacher test. Teacher test because I knew how to write a proof. I did not actually understand everything that was being asked of me at that time. But because she taught me how to write a proof, then I was able to actually pass the assessment. It took me 4 times. Took me about 4 times. So again, math is hard. So I am here because math is hard and I do not want, so I'm switching. Parents, if you're here or if any parent shows up, I'm switching. I'm talking to the students because it's time. It's go time. All right, so like I said, there's a list online of what we're going to discuss. I have a GoFundMe. If you want to support, I would appreciate. And I have Cash App up. All of these things are in my link tree because I do need some resources. But maybe you need to actually see what's up before you say, hey, I want to buy into this program. I'm going to support her. All right, so let's start with, and I gave you my notes, so it's going to look a little squirrely. But trust me. Trust me. So we are starting with what is a variable. Like I said, we doing them there, right? All right, so variable. What is that? So variable means, or another word, synonymous with changing, okay? So this means you don't know. Changing. IDK. So that's going to be a letter. It doesn't matter which one. X, Y, Z, M. We love X. We love Y. Why? Because it communicates. Domain range, slope intercept form, a lot of things. We love those letters. But when you come into a variable, it's just a letter. It's just a letter, and it can represent any value, and it's going to depend on the problem you're solving. So can represent, and again, I don't have my book. I actually couldn't find it. Can represent any value, and this depends. So we're going to start the color code. This is going to depend on the problem. Depend on the problem. We will talk about solving equations in a moment. I don't know how long, but okay, so boom. So I have a variable. That's just a letter. It's just a letter. It could be, we'll talk about that as we begin to solve, but just so we know, a variable can represent any letter, etc. So I probably should have put etc. because I don't want you to think these are the only ones. These are not the only ones. These are not the only ones. Etc. So variable, anything, letter. We don't know what it means until we actually put it into use. So then we also want to say, well, what is a term? Because we're also going to be, like I said, I'm going everywhere. So a term, so these are going to be representative of, I'm going to give you an example. So let's say we have 2x squared plus 3x plus 6. Okay, the terms, layman's terms, help me. That's what I'm saying. I'm telling you right now, I do not have my math book, so I don't have the actual mathematically specific per what was defined prior to the day terms. I have, this is how it's going to be best learned so that you can actually stay with me as I go through. And hopefully you're learning as we're going, so things, because again, you can watch today. I don't have a problem with that. Not that I can't control anything you do anyway, but I'm just saying I do want you to take notes over time, and I'm going to stress that a lot moving forward. But today we're just kicking it. And I just want you to sit back so you can understand what it feels like to be in class with me. But I didn't tell you a funny story about Spelman. Oh my God, I forgot. So I'm sorry, I'm going to pause this math for a second. And we ain't going to be pausing the math, but we got to talk about it. So Spelman College, funny story about, oh my God. So as smart as I am, right? So as smart as I am, as good as I am at math, My GPA was not good, so I was unable to pledge. And I know this has nothing to do with nothing, but this is just a funny story, right? So I went to Spelman College and woke up one day in my junior year, decided I wanted to pledge. But the problem was I did not actively do well my freshman year, so it made it hard for me to catch up going up. So my GPA wasn't high enough to pledge. And that's not funny. But what's funny is the reason why my GPA wasn't high enough because I partied from like Thursday to Sunday. First of all, at that time, Atlanta, I came from South Carolina to Atlanta, so let me stop. When I saw Spelman, it was like, oh, look at all these beautiful black people. I'm just saying. So I went to an HBCU, absolutely fell in love with it. They had the audacity, I did a summer program, they had the audacity to have like a big old block party. So unfortunately, somewhere there's, I party. So I'm partying, so I'm loving this new life. So I party from Thursday to Sunday. I didn't do my homework. So remember to yourself about college. Do your homework first. When somebody's calling you like, hey, let's go out, they done probably done their homework. And if they haven't, still be like, hey man, let me get my homework done before I come. Why? Because you're not gonna do it after the club. I'm just saying. I didn't lie. I'm trying to be honest. I lied. I'm gonna do it when I get back. No, you're not. No, you're not. No, you're not. No, you're not. You might be tipsy. Oh, some more stuff? No, you're not. So, you can party Thursday to Sunday. Make sure your homework done by Thursday. I'm just saying. Friday, fun Friday. Cool, it's fun Friday. That's why you're getting this, because this is not how I teach. I come on extra professional, but this is how I come when it comes to, sometimes. I'm just saying. It's a fun Friday. So that was funny to me because, I did not do well. I graduated. I got a degree in math. I had struggle bus. But that part, because I kept, when I wanted to do what I wanted to do, which was pledge, and I had a 2.9. I graduated with a 2.92, which I'm an overachiever, so I'm not happy with it. But it is what it is. I got my degree. The other 2 degrees, I had like a 4.0 or almost, because I'm a, what? Stop, 2.9. I was so mad at myself. But anyway, moving on. Do your homework. We'll talk about it later. All right, back to terms. So each part. So simplest terms. Each part. Oh wait, that's not how you spell it. Each part. I'm glad I made a mistake because I'm going to make some because this is the classroom. It is unedited. Everything happens. We'll talk about boys. Okay. Not in a bad way. Now, I taught a classroom full of boys and they taught me so much about instruction. So we'll talk about that when I actually get to a forest park or a school. Anyway, so each part, which means this is a term. This is a term. So they're going to be separated. And if I make a mistake, because I might, an operation. So I'm pretty sure, and again, I am not the best math teacher I know. So I'm going to tell you right now, I might make a mistake. So they're going to be these, the terms are going to be separated by plus or minus. So for this problem, then if I'm asking you what the terms are, it is my hope that you would say that the first term is 2x squared. The second term is 3x. So this is the first one. The second one is 3x. And the third one is 6. So each of those are terms. Each of those are terms, if that makes sense. So that's going to be important for when we start talking about collecting like terms. That's going to be important when we are multiplying polynomials and binomials. And I know that might be like, I don't know what language you don't understand, but that's a lot for right now. All I need you to know is what a variable is. That's a letter. Boom. And what a term is, it's going to be the different parts that are separated by plus or minus. The reason why not multiplication and division, because if you notice, multiplication is right there. Now we're going to talk about that later, but when you see a letter and a number beside each other like that, that means that's multiplication. So these two things together are a term. So what's the word? Multiplication and division are not going to separate your terms. The addition and the subtraction are, which means that's another thing. So if I ask you for something, and this is random, it wasn't in my, it's just coming out my head right now, because you need to know. So if you're asked about terms and it looks like something like this, 2x plus 6. Well, you would have to take care of the distribution property, which we will talk about, to get it into this to determine, to just make sure you get the terms. So if it's seemingly complicated, we'll get there. Then you may have to manipulate it just a little bit to get it to what you want to see. So, okay, we're not going there. Most important, what are terms? What's a variable, a letter? What's a term? It is the different parts separated by the operation. All right, let's move on. Let me see where I'm at. And I am going at a certain pace because if I am able to download this video, then I'm going to cut it and use it to upload to my channel. All right, let's move on to, all right. Oh, from that case, then I'm picking another shirt. We are moving on to now, how do I collect like terms? So let me write the next topic up. And yeah, like I'm so mad at YouTube, so I may have to do it again, but I don't know. We'll see. I don't have a washer and dryer at home right now, and I don't want to have to rewash all this stuff, or maybe I won't have to, but anyway. So this is combining like terms, correct? Collecting like terms. So collect like terms. Or combining terms, okay? So that's what we're talking about, and we are moving on to the next story, and I'm going to pick at random. Oh, don't mess up my shirt. Not SC, baby. All right, so I'm excited. Who's next? All right, so this is from that park. I did close my eyes and tried to pick at random, but it's okay because I love this. So this one held so much memory. I tried to wear uniform. This one I got when I call myself wearing uniform, which I know I hate. Let me stop. I hate uniform. You see, I don't even like t-shirts. Notice all these t-shirts cut up. I was a coach, number one. So this is a coach shirt. You'll see Coach Logan. I coach dance, I coach cheer. Oh gosh. But this was funny because this was my attempt at wearing uniform when I was pregnant with my youngest child. And that was when I taught all boys. Here it comes. Oh my God, my boys were hilarious. So I did it twice. So purposefully, they had done a single gender education at Forest Park. And then just by happenstance at Whitlock Flexible Learning Center, I ended up having a class of all boys. Now, in both of those cases, the boys ran circles around the other classes once I got them on. And especially the small, because it was a class of like 3, but that's just the nature of, well, no, the classes got bigger, but at that time it was only 3. And because we had a cool, chill learning environment, they started running circles around my other classes, and it was like I was about to have to start planning for an entirely different class. So I had to slow them down so they would go play basketball. They'd be like, can we play ball? Yes, you're killing me. They'd be giving all the answers away. Victor Cortez, he'd be in the test like, yo, Miss Logan, is this a max or is this a max? First of all, that's a great way to teach it. So when we get there, we'll do that. Second of all, I can't answer that. That's not giving the answer to the test. So Forest Park coaching, the funniest, this one's more epic than funny. Okay. I coach dance, and I didn't get to dance as a profession, and I do regret that, but it's okay. I don't get the opportunity to do that. I'm cool with that. I know that leadership is my next role, so that's fine with me. But coaching dance was an experience that I didn't expect to be as enjoyable as it was. And so I coached the dance of girls with band, think drumline for the type of band and dance that we're talking about. So I'm a perfectionist. I'm a competitor. And so my girls, there was an end of the year competition called the Jamboree. And so at the Jamboree, you competed against another band. And in like maybe 4 or 5 rounds. I forgot what the rounds were, but one of them was band dance. One of them was where you featured your dance team. And then they had some where they just battled with playing songs or whatever. So, okay, my realm is band dance only because I gotta, make sure they look good for the band dance or whatever. And then their dance. So this particular year, I decide we going for Mike, right? So we going Michael Jackson. So I choreograph and this video is out there. So if my girls catch this, somebody please share this to Facebook, share the link. I don't know where it is, but share the performance. Anyway, so I decide to do Michael. I choreograph a piece for the girls. Fabulous. We wear black pants. They got white socks. We may not have done black shoes only because we were doing dance shoes and I wanted to keep their feet safe. So we might have done our brown shoes just at the time and to save money. But they had black suspenders, white shirts, black hats. So I'm a little bit, again, competitor. So we on the bus, and I said, when you step off this bus, you are in performance until we take the field. Because the strategy, again, we come to win. So the way the performance played out is the girls were going to come through the back of the, so you wouldn't see them. So the band starts to play, they start to play song, the girls come through the back. Now, because the girls came through the back, I ended up, because I was like, dang, Mike is missing something. So I got the hottest male dancer in the school to play Mike for me. So we got him a wig. I love that he understood the assignment. Oh, except he couldn't do Mike. Oh my God, he couldn't do Mike. Like, that, he couldn't do it. He couldn't do it anyway, but either way, he still killed Mike. So they come through the back. The girls kill the performance. Like, they kill the performance. So somewhere in the middle of the performance, because they noticed, because the girls are killing the performance, nobody noticed that Mike actually came through the band as well. So he comes in probably about 3/4 way through the song. The crowd goes crazy. The girls kill the performance, and then they shed all of their clothes, and they do the band dance because they have on like a unitard but with shorts, and it was black and gold, and it killed. It was like the best performance ever. It was. I really enjoyed it. And it's that moment where you see your work. So I'm not actually doing the work, but I see my work. So that is a coaching story. At least, yeah, I'm going to go coach and dance for this one because that's who I was coaching at the time. And then the boys, that was the other thing that I learned, that I had to teach with the door closed because I was coaching dance at the time. And if one of my senior level girls came in, because I was teaching 9th grade boys, have mercy. So 14-year-old boys, 17-year-old girls, you do the math. When they came in, I would lose the class. What's her name? What's her name? You tripping? I can't get a number? No, I can't. I'm sorry. No, that's wrong. I can't give you her number. Dang, so you tripping? No, I'm not tripping. Anyway, so love them. Had to teach with the door closed and had to tell my dancers, you cannot come during 4th block. That was 4th block. That's when I had my boys. You cannot. I love you. I know that's your lunch break, but you cannot come because it is too disturbing. So, on to the next. We'll combine the like terms. I'm only going to do one problem, I believe. And I'm trying not to go super fast, but I'm on coffee and I'm about to go get some more. Anyway, so let's look at this problem. We have 6x squared. Or 6x squared plus 3xy plus 4x minus 2xy minus xy. So I'm probably going to go a couple of places with this because I want you to be able to solve this, period. You know? It's 11 and I'm only on the second problem. Hey, Space! Bring them on video. Oh, I can't necessarily bring you on. But hey, sir! Welcome! I got to focus on the math, but love you. It's good to have you. Okay, so, like terms. So first you need to identify. This is where we're going to do some color coding. Because I want to make it easy for you. You want to, so first of all, we have 1, 2, 3, 4, 5 terms. But we need to identify which one of those terms are alike, right? So we have 6x squared. So x squared is the first variable value we have. Do we have another value that has x squared? We do not. So that is the only one that can be combined, meaning there's nothing to add or subtract to it. Now we have 3xy. So xy is the actual variable situation. So we're looking for anything that has another xy. So I have a negative 2xy and a negative xy here, okay? So those are alike. And then I look for the last thing, because remember I had 5 terms, and the 5th one is the 4x. All right, so we have 3 groups. For the ones, and I did not discuss this. We will talk about, nope, I'm not going to go too far. I'll bring it in when it's relevant. Let's just talk about combining. So, we're combining. So, the first one is 6x squared. Since there's only one green value, there's no other x squared term, we rewrite it. I will talk about descending later. That's where I was going to go. It's kind of relevant, but I need to talk about degree before I go into great detail. So, okay, cool. We only got one of those. I like to cross it out because then I know that I've already resolved it. Now, I have 3 of the blue values, right? So for the sake of argument, I'm going to put them in parentheses so we understand. So 3xy is the first one. Cross it out. Minus 2xy is the second one. Cross it out. Minus xy. Now, because I don't assume that you know anything, then, because that's not fair. Like, if this is the first time you've ever learned about combining like terms, then there's some things you don't understand. So I'm going to go and make sure that I clearly articulate everything, because this doesn't look like there's a number sitting there. Like, what is that? Negative xy. I don't know how many of those. I know that I got 3 xy's here. I got negative 2 xy's here. What does that mean? When you do not see a number, in front of a value like this, then there is a 1 there. So again, oh no, what I'm going to do here is we've combined that. We'll go next. We're going to go ahead and drop this down because there's only one of those. So 4x. So hopefully I didn't confuse you, but I wanted to go ahead and collect all the terms. So we've got 6x squared had one of those. So 1 term. Then we got 3xy, negative 2xy, negative xy, all in parentheses. We're grouping them together because those are the ones that we can combine right now. And then we have 4x because there was only one x value. So we still have our 1, 2, 3, 4, 5 terms. So just so I'm gonna keep talking about the things that are relevant to your learning. So because the thing is, if I keep repeating it, then at some point when you're in class, you're gonna hear it. And it's going to be like, she said terms like 70,000 times. I know what a term is. And that's the goal. Not at all to be condescending in any way, but repetition is how we learn. Okay, so cool. We have 5 terms now, but we're going to combine, so that means that we may actually not have 5 terms in the end. So 6x squared, we bring it down because there's only one of them. But, again, I want to go one more step with this because I want to make sure that we all understand that there's a 3 in front of this one. There's a negative 2. So add the opposite. No, that's too fast. Nope. So negative 2 here, negative 2xy. And then if you don't see a number, then that is one of those things that we assume in mathematics there's a 1 there. So we assume that you know. So I'm not going to assume that you know. I'm going to explain. When you don't see a number sitting there, like physically typed there, and there is a 1 there, you put a 1 there, or you know that a 1 is there. Okay, and then finally, 4x. So one more step, just because I like to be thorough. So we're going to bring the 6x squared down. We are going to group the numbers together. So I have 3 minus 2 minus 1 x, y. Ooh, something just happened that I didn't expect anyway. And then we bring the 4x down. So again, we're now actually completing the combining process. All right, cool. What is 3 minus 2 minus 1? Because that's the only thing that has to be simplified here. 3 minus 2 is 1. 1 minus 1 is 0. Ooh, I love that happens, because now we can talk about what happens when 0 is multiplied. No, that's not. When 0 is multiplied by anything, okay? We're going to use that at some point. All right, so what just happened was, when you have a 0 multiply anything, that entire term goes to 0. 0 times anything is 0. That is the multiplicative property of the 0 multiplicative property. 0 times anything is 0. So 6x squared plus 0 plus 4x. So we actually end up with 6x squared plus 4x. So right here, just for the sake of argument and learning, we had 3 terms. But based upon that going to 0, we end up with 2 terms. And I'm only carrying it because we have so many things that we're going to talk about in that way. All right, cool. So that's the Forest Park shirt. That is the Forest Park coaching shirt, that is. And that is combining like terms. Outstanding. So now, let's erase. Hopefully I'm not moving too fast. And hopefully me lowering my voice is not problematic. Because my daughter said she could hear me from upstairs. And again, so that's the whole point. I need a space to record. So I need a classroom where I can just be me. I need a classroom where I can just be me. I need the space to speak the volume that I need to speak. I need to be able to record. I need a projector. Where are we going? We are going. So please, please, please support. This is a fundraiser, and I am trying to build curriculum as well. So I'm not, yeah, I need help. All right, so in any dollar amount, my link tree is where you can support if you want to help. Distributor property. So we're doing the distributor property now. Distributor property. So what is that? All right, we are doing the distributed property next, and we are changing. So I'm also going to use these breaks to cut my videos. So if I am able, hey, okay, this is for Whitlock Flexible Learning Center. So this is the last school that I taught at. What? God, epic. First of all, Ethan Martin came to the call. I don't know if he's still on it. He attended Whitlock, one of my babies. And I call them babies, but they're not babies. They're not. By any means, they are not babies. But, all right, so Whitlock. Oh, my God. And first of all, kids always eat your snacks. Let's be clear. As an educator, yes, if you eat around children, they're going to eat your snacks. But I would have broccoli or mixed nuts, and it would be like, what you eating? Dude, I'm eating my snack. Let me get some of them nuts, though. They honey roasted, too? I'd be like, bring me some. Here, I'm going to give you the money. Because they couldn't have their phone. Oh, and that. Okay. At Whitlock, they couldn't bring their phones. At least they weren't supposed to. Now, we won't go there. But they weren't supposed to. So, I would have students, especially my young ladies, Miss Logan, let me see your phone. Every time. I'd be like, all right, I don't know. I just be saying yes. Sometimes I should say no. Anyway, so I say yes. Every time I got my phone back, there would be like 7 pictures and 5 videos. It would be some TikToks. It's like, yo, what? Then I would say, don't take no pictures. Don't do no videos. And they'd be like, okay. And next thing I know, I got pictures in the bathroom. Dude, you gonna get me in trouble. So I love them. They're so funny. They were so funny. Oh God, they were so funny. So I'll probably talk about them more because they also gave the best shirts. Like the Navy, fit. So anyway, distributed property. So I'm not gonna go in great detail, but I am gonna go in enough detail. Like I said, we went to the marathon, so we just gonna go as fast as we can go. Let's look at this problem. We've got 4, 2x plus 6. Ooh, we got some new things we need to introduce. That's it. I'm gonna do 2 examples for you. All right, so, yes. Okay, so no. In an example like this, parentheses here means multiplication. Okay, so using the distributive property, so distribute, to pass out, to hand out. So like, let's say somebody's handing out papers. I know we don't do that quite as often as we used to, but they're distributing the papers to the class, so they're handing it out. So think of that concept when we're talking about the distributive property. So you're taking what's in front of the parentheses and you're distributing it to what's inside of the parentheses. So you're handing it out, so to speak. So we've got this 4, and then we've got the 2x plus 6, right? So this is multiplication. So you're going to multiply. So I'm going to step 1 here. And I'm going to do these not in general, but they are kind of general, but they're going to be specific to the problem. So our first step here is going to be to multiply 4 to the parentheses, okay? All right, so that means I'm going to multiply the 4 to the 6, the 2x and the 4 to the 6. And I'm going to write these steps out because I'm teaching and I want you to really understand. So this is going to be 4. Now with multiplication, that dot means multiplication. So your symbols here, this means multiplication, parentheses means multiplication, and x means multiplication. And then if you see something that looks like 3x or 1/2 x, those can be, in this instance, this is a fraction multiplied by a variable. In that instance, that's a whole number multiplied by a variable. Let me use the same grouping symbol. All right, so, boom. Now, we know that those are different ways that you can see multiplication, and they all mean multiplication. So this is just something that over time we need to be aware of because it's the presentation. All right, cool. So we take the 4, we multiply it times the 2x, and then we're going to keep the symbol or operation that we see. We're going to also now take that 4 and we're going to multiply it times the 6. All right? So then our step 2, let me try to keep our step 2 for this specific problem. I've generalized in many lessons, is we're going to multiply and simplify as needed, okay? So in this particular situation, we also have the 4 times the 2 and the x. So here, you just multiply the numbers. We'll talk about multiplying variables when it becomes when it becomes relevant. So right now, it's irrelevant, but we will need to address that. So here, when you're multiplying in this way, you multiply the number times the number, and that's what's important. So the 4 times the 2 here is going to give us 8x. And then the 4 times the 2 here is going to give us 24. So this is your final answer. Because these are not like terms, so that's why I started with term and then moved to like terms. This is the final answer because these two things cannot be combined. They are not like terms. To combine them, this would have needed to have an x, or this would have needed to not have an x. But since this one has an x and this one doesn't, then we can't combine them, and this is the answer. Okay? Now we're going to do one more example with hopes, and I'm going to, I just, when it comes to certain things, I want you to be able to see it twice. So I'm going to erase this, and I'm going to erase this. And we're going to do the same thing, but with a different example. Okay? Oh, God. I'm recording.
Why not?
Okay. I'm recording. I tried to lower my voice, but I'm going for some hours.
You going for hours?
Yes, I am. I'm live now. I'll try to keep my voice down as best I can. Okay, next problem is 3x. Oh, good. Go ahead, Miss Logan. 3x. Oh. All right. So 3x times 2x plus y. Okay. So now, remember when I told you it wasn't relevant? Well, it just became relevant. So we now have to add. Okay. So I'm going to add another note that's relevant to this problem. When it's relevant. Step 1, multiply 3x. So step 1, multiply 3x to the parentheses, okay? I'm slowing down because I want to follow the same procedure. So the first thing we do is we take this, we multiply it to both parts. So 3x times 2x plus 3x times y, okay? So in the multiplication process, so now we need to talk about what happens with numbers. So with numbers, multiply the number and then simplify. With variables, multiply, rewrite. Okay? So example, let's say, let me get out the way. We multiply and rewrite. Example, so if we need an example, multiply, so that's going to be 2x times 3. That's going to give us 6x, right? Okay, boom. But let's say we have m times n. That's going to give us mn. Because those are not like things, we cannot do the next procedure that we're about to follow. You would just rewrite it, okay? Now if you have both. Nope, not both. With variables. That are alike. Okay, so these are different. Notice the m and the m are different. The m and the n are different. So let's say we had, example here, m times m, right? So that's going to be, now this is another thing. So this is why I'm doing this, because I don't really know the supplemental things until I'm actually into the standard and teaching it. So there are things that I had to do this side work, so you know how to do this. But anyway, so we're going to keep moving because this is a little different. What happens is, so remember how we had the x, y, and we had the 1 sitting there, right? So a similar thing happens when you have variables and you don't see anything, you don't see an exponent. So, okay, we haven't talked about exponents. Exponents are the little number that sits up. So remember we had an x squared. That's an exponent, all right? And I know that's really quick. Another example. The 3, that's the exponent. Y to the 6 is the exponent. Okay, so you'll see a number there. But if you do not, and that's why we're talking about this right now, there is an implied 1 there. Always. If you don't see a number, there's a 1 there. And that's important because when you multiply variables times like variables, you add the exponents. So you've got m1 times m1, that equals m to the 1 plus 1, and that equals m squared. And so that is important because when you're multiplying here, and I didn't realize I needed to kind of give you that front loading here, but that's okay. I'm gonna explain it as I go. Exponents are important because they, especially in the multiplication process, as we're doing monomials and binomials and polynomials, and we'll get there. But for now, we just need to know if you don't see a variable there, it is 1, and you need to, for some of us, put the 1 there so you know how to add. Because if you don't, then you'll forget it. It's never a 0. If it were a 0, you wouldn't see it. We'll talk about that later. So right now, if you don't see a number, there is a 1 there. And it's never going to be given to you. It's always going to be implied. The expectation is that you know. So no number in front of some variables, there's a 1. No exponent visible, there's a 1. All right, so that means there's a 1 here, a 1 here, a 1 here, and a 1 here, right? Now, because these are different variables, boom, different variables, we just going to rewrite it, all right? That stays 3xy. These, we've got some numbers that we need to multiply. Did I put numbers? Yeah, the 2 and 3 here. I did put the variable, but this is this example where we multiply the numbers. So we're going to regroup for the sake of argument. We're going to multiply the 2 and the 2, and then the x to the 1 times the x to the 1, and we're going to simplify. So step 3, because we have to figure out how to multiply. In step 2, which one of these things apply here? And then our step 3 for this problem is going to be to simplify. Okay? All right, so we've done that. Now, 3 times 2, 6, x to the 1 plus 1, plus 3xy. No, I wouldn't necessarily, well, I'm lying. In introduction, I would start this way. Over time, I won't always do that for you. But introduction, and since we're introducing ourselves and I tend to run and have a level of expectation, I set the groundwork so when I do get to a level where I believe you should be able to perform, I'm not going to be doing things like this. Only because I know that I've taught you that way. So I am going to be like, hey, if you don't understand it, go back to this video or go to this video or check out this resource. Because when I've laid the foundation that I kind of stand on, we should have this mastered by now. I am going to create assessments so that I can help you to check your knowledge along the way. Hopefully I'll be able to partner with education, but that is not, it's a struggle. It was a struggle prior to today, so I'm going to teach the math, and then we'll deal with that later. So the only thing that's missing right now is we had a 1 plus 1, 2. Now, here we are. Is this the final answer? Yes, because x squared and xy are 2 different terms. So our final answer has 2 terms. Okay? 6xy, 6x squared, 3xy, those are different. This is as far as you can simplify it. And in all things, you do have to simplify. So as you're learning these concepts, as you're going to the test answers are going to be in simplest form, so you do have to learn to simplify it. So you cannot keep it, we'll talk about that more later. But that's the end of that. So we're moving on past the distributive property, which means we're changing shirts and we are moving on. So that's not bad. That's only 11:13. I've covered how many concepts? 1, 2, 3 so far. Now we're going to solving equations. Let's go. Yeah, that's going to be fun. All right, so I'm going to do solving equations slowly. I'm going to talk about a lot of things. So we're going to go single step and then double step for equation solving. Single step and then double step. Single step and then double step. All right, take off these glasses. What did I say? We're doing solving equations. Solving single step equations is where we're going. Solving single step up. All right, so we're solving single-step equations, and we are taking a mini break, and I'm closing my eyes, I'm closing my eyes, and I'm randomly, okay, so like I said, I taught in 2 states, right? We know that I taught at Forest Park High School, right? And we know that I also taught at Whitlock Flexible Learning Center, right? And then there is the Den, Westlake High School. So I spent, oh my God, Westlake. I was at Westlake when we came back from COVID. It was terrible. It was good for students because school is great for the socialization of society. So it was great for them to get back, but since they had not been together, then it was just a lot of anxiety is the best way to describe it. So there was a lot of fidgeting, there was a lot of up and down. They had been in front of the computers, they could go when they wanted to. So saying sit here and listen to this person was very difficult because I also taught before we returned from COVID. So I had to do the virtual, the simultaneous. There were some kids in class, there were some kids online. Them kids would be asleep. The parents were like, hey man, I need you to do so-and-so. Hey, Miss Logan, I gotta go. My mama said I need to go clean up. My mama said, wait, what? Your mama know you in class, right? So it was a struggle. And when they came back, there were gaps. They did not want to write. And I don't play that game. So, but anyway, Westlake. I loved it because they were just fierce. It was like a mini HBCU. And so they just are some just heavy hitters, outstanding educators, great place to be. And it was good to be a part of the Den. And I just was going through so much at the time, I didn't really get to appreciate it, but it was a good place to be. So much love. And my baby, my oldest, went there for 2 years. And actually, that's where the teacher who told her that she would go into writing. And sir, if you catch this, she did. Anyway, so let's go to single step equations. Now we're going to do this one. All right, we're going to do this one at a time. So this one, we're going to go addition. And if addition, so plus sign. So this is a fundraiser. I am a math teacher. I am building a YouTube channel relatively by myself right now. I hope to bring on more educators with me. I want to be a new voice for math education. And so I am, first of all, front-loading standards for students. These are the standards that I saw were weak in 9th grade. And so I'm trying to these are the things that everybody in algebra need to know, everybody in geometry needs to know. But I am seeking help to continue. I need some things, maybe rent a classroom because this is a little difficult right now, but it's possible. So I'm going to keep going for the kids, but I would like some help. So I've created a GoFundMe and I have Cash App if you are willing to send me some funds to help me keep going. And I'm gonna keep going, but I just would like some help if that's cool. So back to that math though. Addition. So we're gonna do this by the single properties at first. The operations at first. Because I don't want to move too fast. So we're gonna do addition. X plus 7 equals 14. So x plus 7 equals 14. So we're going to follow the same process. And if you're with me, hopefully it will flow once we get there. So our step one. Step one is going to be to identify the operation we see. All right, so what does that mean? First of all, our operations are this. So what are operations? Oh my gosh, Miss Logan, you're saying stuff I don't even understand. So what are operations? And we're going to talk about the order of operations, and I already have a video out there, so you can check that out. But the operations are, we might as well hit it real quick. So this is your PEMDAS, and most of you know that as far as PEMDAS. Now, whether you know what everything stands for all the time, I don't know. Whether you remember how to use it, I don't know. But this is relevant for right now because as we solve equations, that we're going to have to follow the order of operations, and we need to know what all these things mean. So P, we already talked about parentheses, but that's what it stands for. We'll talk about what PEMDAS means as far as another acronym as well. So E, that's going to, parentheses, so that's parentheses in any grouping symbol. Okay? SYMBOL, so that could be brackets or braces, as well as parentheses. All right, so then the E stands for exponents. We already talked about that briefly, so that's going to be your x to the 2, y to the 3, z to the 5, whatever, that little number that's sitting up there, that's an exponent, or if we don't see it, remember that's going to be a y to the 1. All right, cool. We've got M. Now, M is for multiplication. So that's we talked about this different ways you'll see multiplication. And D is for division. And so that's this symbol, or it can be a fraction. Like if we have 6 over 2, that's also representative of division. I'm not going to spend no time with fractions today. Not going to do it. But you do these from left to right. And I had to kid it. I'm sorry. I know I didn't. So this is the order of operations. But it's important to solve equations, so I should have talked about it. We just going to take this side note. Order of operations. And I'm going to erase it once I get past. Well, I might. It depends. I know we're not taking notes, so if we're not taking notes, then I might leave it up there. All right, boom. So you do those for left to right, and then, so first parentheses, you clear the equation of the parentheses. We'll talk about it. First, then exponents. You clear the equation of exponents. Multiplication and division. You clear of multiplication and division from left to right, which means if division comes first from left to right, you do the division first. You don't go find the multiplication first and then do that and then come back. No. So if I had, I don't know, 3 over, 12 over 4 plus 3x, plus 3 times 2 minus 6. Wait, no, not like that. It needs to be written like this. All right, cool. So let's say I have that. Well, division comes first. Then I would do the division first. I wouldn't go here and do the 6 first. That's just not how that works. Because you'll have parentheses, you'll have other things just, so from left to right, first thing I would do is simplify that to 3. Then I would simplify that to 6. Then I would write that. Then I would simplify it again. So just as a quick, that's how you handle that. I know I'm moving fast, but I also know you're probably just watching if you're here, so you ain't taking notes. Love you. All right, so then we have addition. So A, and then we have S. So addition. And so that's where we're starting. And subtraction. Minus, same thing, from left to right. All right, so that was a random side note, but it was relevant for solving equations. I'm going to leave it. So step 1, we're going to identify the operation we see. So what do we see? We see addition. All right, purposely. So we see addition. All right. Use the identify. Okay, so because I want to go slow. So then the next step, step 2, is to be identify the opposite operation. So what are we going to use? Well, if I see addition, then I have to use subtraction. So I'm going to use subtraction. All right. So I C plus, the opposite, and we actually can come here. So these undo each other, these undo each other. We'll talk about that a little later. But as far as the opposite of addition is subtraction, the opposite of subtraction is addition. So that's why we starting there. I'm going to erase that. We're going to move on. All right, so I see addition. I use subtraction. Now I'm going to subtract the value. So I'm actually going to apply the opposite operation. So use it. So simplify. I want to simplify. That's what I want to do. Simplify. So I want to use, let me do that, use and simplify. S-I-M-P-L-I-F. y. All right, now why that is important is because we've identified addition. Boom, plus sign. We know we need to use subtraction, so I'm going to say the plus 7, I'm going to use minus 7, and I have to do that to each side of the equation. Now let's talk about balance. Some of us need to do this to make sure that you put it on each side of the equation. If that's what you have to do to organize your brain, don't let anybody tell you that you're wrong or that you anything. Don't make anybody know. Whatever helps you make sure that you put it on both sides of the equation, because you have to keep the equation balanced. This is applicable in science as well. But here, you have to keep the equation balanced. So anything you do to one side of the equation, everything, anything done to one side of the equation must be done to the other side. Okay? So what happens is sometimes, and I know that somebody's gonna be like, you shouldn't have to draw that line. I know how people make you feel, because they make you feel stupid as well. But don't worry about it, because what happens is I've seen students, and it's not their own fault. When you don't do it, you'll hit me with that. So you'll know you need to subtract the 7. But you put it on the same side of the equation, which makes it difficult to solve, because now I don't know what can combine. Again, we talked about combine learn. I can combine that, but what am I doing with that? And then I do nothing with that. So the line helps you realize, okay, I got to do something to one side. I got to minus this 7, because that's how I can get that to go to 0. Then I got to do something to the other side. This lets you know the value, where the sides of the equation are, so you know where to put the value. All right, cool. Once I do that, I then simplify. So I saw addition, I use subtraction, I applied it. 7 minus 7 is 0. So x plus 0 on this side is equal to 14 minus 7 is 7. We don't write that 0. We don't write that 0. So x equals 7. So that's going to be your solution. So for this problem, x equals 7. Now, if you want to check your work, which you do not have to, but you can, just to make sure your answer is correct. We generally don't do that as of late. But if you want to, then you would just take your x, because that's what a variable is, right? So remember I talked about a variable, we don't know what it is. Well, we don't know what it is until we solve the problem. But we solved the problem. We know that x is 7. So just to check, we're going to check to make sure we're right. So I'm going to take the x. My original equation is x plus 7 equals 14, right? I think, based upon my calculation, that x equals 7. So I'm going to take the 7 out, substitution, bring down the other parts, now plus. And if the sides are equal, then my work is correct, and I've found the right solution. Well, 7 plus 7 is 14. That is indeed equal to 14, so my answer is correct. I am not going to check every answer, but I just wanted to show you that you can self-check if you want to. All right, so now that we have done addition, we're going to do the same thing. So we're going to run through for these the 4 basic operations, which are addition, subtraction, multiplication, and division. Now, because I've already talked about that, no, you're not taking notes. All right, so if you're not taking notes, and I'm going to assume that you're not, and that is totally fine, then I'm going to leave our side notes up, okay? That way, as I deal with the order of operation, then, all right, so this time, we're still working with single step equations. Now we're going to use subtraction. All right, so we're using subtraction. That's what we're going to see. Oh. All right, so the question is m minus 6 equals 20. All right, so m minus 6. All right, so we left the steps up there, right? We know that the first thing we need to do is look at the equation. Now, variables, our variable is what? M. Doesn't matter that the letter is M. I'm just saying. We're reviewing things that's going to come. Identify the operation we see. Well, I see a subtraction sign, so boom. If I see subtraction, I see subtraction, right? Cool. I'm going to come down here, because I know I need to identify the opposite operation. Well, subtraction, the opposite of subtraction is addition. Cool. So I'm going to use addition. All right? Now, I need to actually use it. So identify what I saw, identify what to use. Now, so I'm going to put because I'm abbreviating, but that's because I'm on flow mode. So now we're going to use it in simplify. So first we subtracted 6 from each side. Now, see subtraction, use addition. I'm going to add 6. I'm going to draw that line because I'm going to let you know that I don't have a problem drawing it. So I want you to not feel no type of way while you're doing your work. And at present, your assessments are online. So the EOC for Algebra 1 is online. Most final exams are online. Sometimes you need to get the scratch paper as they give it to you and write down these problems so you can work it out. And I know that's not what you want to do in most cases. And my kids hated word problems. They just skip them. We can't just skip them because we need all the points we can get. You absolutely fail if you don't try. But sometimes, like I literally passed the test on I did what I knew. I eliminated some answers. And then I guessed for the rest of it, and I messed around and passed because I did it from a place of I'm gonna answer what I know, and then the rest of it I'm gonna make educated guesses, which means I'm gonna eliminate answers that I know it can't be. So we want to do the best we can because sometimes we need that extra point or two to get to passing. All right. Anyway, we're adding 6, so we know that negative 6 plus 6 is 0. So 6 minus 6 is 0. I haven't talked about positive and negative, so I may actually need to go there. But 20 plus 6 is 6. So this minus or plus 0, whatever you like, you don't have to write it, to be honest with you. In class, I wouldn't. We've crossed the bridge. We know that 6 minus 6 is 0, so I would just let you know that those eliminate. That goes to that. We add equals. All right, so m equals 20 plus 6 is 26. So my final answer is m equals 26. I am not going to check it for you because we already talked about that. You don't have to do that, but you can. And if you do, then you know you take that 26, you substitute it in here, and 26 minus 6 does indeed equal 0. So it checks, but you don't have to all the time. Boom. All right, so that was subtraction. Oh, I was supposed to change clouds. Okay, so I am running fast. All right, so now we're going to go to... Because how many shirts do I have? Oh, I do have several. All right, so we're going to do multiplication next. Multiplication. And I'm going to... So that, y'all know all the numbers. I'm going to put X because, you know, that's what we use. But, I'm going to be strategic. Who haven't I talked about? I already talked about. Who haven't I talked about? Talk about you. Oh, so I would have chose this one. This one is for my girl HG, wherever you at. Yes, it's messed up because HG, I need a new shirt, but it's also for the A because I miss my home. I'm just saying, I can't wait to get back to Atlanta. And am I a fan? I was given this shirt. Yes. I don't know. I'm from Iowa, so, and yes, there are other black people in Iowa, but yeah, so I'm from Iowa, so I really don't have a dog in the fight right now. For real, I haven't said, yeah, this is my team. Just me. I do have a basketball team. The Suns are my preferred, but that's just that. So football, I'm from the Atlanta area, hypothetically, you know, I spent 20 years there educating the masses, so love Atlanta. Been to a couple of games, supported the Falcons. Who am I, but they struggle playing as a team. I'm just saying. Anyway, at least they did when I was there. But the shirt matched some shoes, and HG understood the assignment. So that's all I'm saying. All right, we're going to multiplication. Oh no, the story. So the story. Okay, so for the story, this was when I was in leadership. So there's an outfit because I left. When I left, so there's a video on this channel that's the Monday check-in. It's funny. I would check it out if I were you. But, well, on my YouTube channel, the math one, TC Homework Help, Miss Logan's. Anyway, so, it just was a lot. I lost my track of thought because I think I was, because I left with, that's what it is. I left angry. So in the video, I say, you know, be less angry. I'm still working on that. That's one of my daily, I got some reading to do, meditation, yeah. So just a little bit. So, okay, boom. I left Clayton County angry. My heart was broken, and I destroyed everything from that building as far as all of my gear. So I don't have anything geared. So the last fit is something I wore, and you're just gonna have to see it when we get there. It's 11:34, so we'll see. But no, you're gonna get the leader fit. So whatever happens, because I'm kind of rolling through the mask kind of fast, and I don't want to waste a whole bunch of time with the stories. But yeah, so the funny thing about the story is this one's gonna be from Melvin Dean when I actually pull it out. So, not Melvin, Melvis Dean. So Melvis Dean, bless his heart, whom I love, his high school principal came to me and said, I don't know how you got that boy that graduated. Rest in peace, Miss Woods. She sat that boy beside her desk and made him do his work. But anyway, Melvis Dean missed the day that I wore said outfit. So I'm gonna replicate the outfit as best I can for this video. You're gonna have to bear with me. I'm gonna go change clothes. But anyway, the day after he comes to me and says, I heard you look good yesterday. Melvis, you can't say that to your principal. And he meant it with his entire soul. So, I'll give another funny story when I actually get dressed in that one. But that's why there's one outfit that's not actually t-shirt oriented that's gonna be on this once I get there. Yeah, because I destroyed all my gear. I'm actually gonna ask. I got somebody in mind. I'm gonna put out a phone call. Or HG, make me a Perry Senior shirt. That's all I'm saying. Hopefully you'll see this. Please, we'll discuss. I actually need to call you. Anyway, that's neither here nor there. All right, so we are now on multiplication. 3y equals -36. So we have not specifically talked about something, and I have to do a pivot. So I have to replace the order of operations bracket with positive and negative numbers, okay? Because this is the second or third time I've kind of just, I can't not discuss it. All right, so there are some things that are important right now. So I'm gonna go ahead and block this space off for side work. All right, so we've been dancing around this topic of positive and negative numbers. I'm gonna write what's, okay, or just the properties around what we need, okay? So for this piece, positive, negative. Now, we're going to talk about that in more detail when it's relevant as far as just, I'll address it as needed. Because what we need to know here is this, that a positive times a positive. Okay, so plus times plus equal a positive. So I'm only doing that so we know when I start abbreviating, okay? And, okay, and a negative times a negative, so boom times boom equals a positive. So that's why it's like, yo, what are you talking about? When it comes to, this is one of those things you have to know, okay? This is one of those things you have to know. So a positive times a positive is a positive, a negative times a negative is a positive, right? So a positive, so a plus times a minus equals a minus, and a minus times a plus equals a minus, right? Anytime, okay, nope, I can't say anytime. When the signs are different though, if there's a negative involved, you have to consider that a negative times a positive is a negative. And I only say that because it depends on how many values we have, and I don't want to make any generalizations that aren't actually applicable. So in this moment, a negative, because some of these things were not, when I taught at Westlake, there were some things that came in properly, and I was like, no, baby, that's not true. And I had to correct some things along the way. So I just want to set some groundwork when it comes to how we deal with numbers. So that is in multiplication. So similar, a positive divided by a positive equals a positive. A negative divided, oh, that's not negative, that's a 1. A negative divided by a negative equals a positive. A positive divided by a negative equals a negative. And a negative divided by a positive equals a negative. So it is important that you know these things, okay? And then we'll talk about the addition of the positive and negative, which I did not clarify, but right now it's not relevant, so I'm not going to put that into your brain until we're actually ready for it. So right now we only need to be thinking about how positive and negatives relate to each other with respect to multiplication and division. We'll talk about the rest of it later. So, positive, positive, positive. Period. Division or multiplication. Okay? Let's get it. I like tables. I like to organize things. Okay, so we've got this. This is what we're talking about. This is what happens when it's both values are positive, both values are negative, different signs, different signs. Let's go. All right? So that's for you. All right. Now, but the steps are the same when it comes to certain things. So now we're ready to solve. I just had to lay a little bit of groundwork. Now we're ready to solve. Identify the operation we see. I see multiplication. We talked about it. So this is multiplication. From the order of operations, we know that multiplication and divisions undo each other. Okay? So if I see multiplication, I'm going to use division. If I see division, I'm going to use multiplication. I see multiplication, so I'm going to use division. All right? So right now, this side is multiplied by 3. The goal is to solve. Ooh, I didn't say that. My God, how have I talked so far and not said that? The goal, sorry y'all, is to solve for here, y. Okay? So you want 1y equals something, or 1x equals something. So it's not going to look like that. The goal is to get a 1 in front of your variable, okay? You're trying to simplify to get a positive 1 in front of whatever your variable is. I am so sorry. That should have been said long ago. I've been solving equations like you understood that and like you knew that. That's not okay. Okay, so everything that I've done up until this point, we were solving to get the single variable to like actually find the solution. In finding the solution, you have to simplify it to the 1, okay? My bad. So from that, and I'm not going to go back and do the other videos because I feel like I was relatively clear. We were doing it, I didn't articulate the y and I needed to. And so our goal, solve for x, y, m, n, whatever it is. So solve for this y to the 1 exponent, right? Okay. We have a 3 in front of it. We cannot have a 3 in front of it. We need a 1 in front of it. To get that 3 to a 1, we have to divide that value by itself. So I see the multiplication by 3. So we're going to get a little bit more detail. So I see the multiplication by d. That means I need to divide by 3. So I'm going to divide both sides of the equation. Remember, whatever we do to one side of the equation, we must do to the other, right? Okay, cool. So we have a positive 3 divided by a positive 3 and the y. That, anything divided by itself is 1. So 3 divided by 3 to 1. Now, I just said something that I hadn't said before. So, anything, sorry. Well, I'm not sorry, only because this is what happens with math. So that's what's happened. I look through the curriculum like geometry. I look through curriculum, what's supposed to be taught in the beginning. There's so much stuff that has to be taught with it. And I don't have time right now, because it takes a lot to upload. So that's why we're doing this in this way. Because when you're working a problem, you really don't know what you need until you get there. But how many standards have I pulled in just trying to solve an equation? And so that's what's happening as I look at the curriculum. And I'm like, okay, I'm a student, right? I'm a student. I'm learning something. I got myself on the curriculum. I just came off of summer, right? It's going to take me a week to wake up. I'm used to sleeping all day. So you want to hit me with, I think, arithmetic sequences? Some of you have no idea what I'm even talking about right now. Math people know, but at the beginning of the school year, no, I'm tired. So because I'm seeing the gaps, that's why I'm filling it in. So this is how I would do test prep, because anybody who missed anything throughout the school year, I'm catching it anyway. I'm teaching it like you never saw it. And so that's what I'm doing. All right, so like I said, anything divided by itself, there you go. By itself, example, 3 divided by 3, x divided by x, y squared divided by y squared. It does not matter. Anything divided by itself is equal or simplifies to 1. Okay? Okay. Because the y was still there, the y will sit there. But the 3 divided by 3, that simplifies to 1. Now, over here, you have negative 36 divided by 3. Now, we do know that a negative divided by a positive, if we don't see a value, we can assume that that's positive. I haven't said it, but I've been doing it a little bit, and so I'm sorry. There are a lot of assumptions, and that's why we're here. If you don't see a number on the value, then you can assume that it's positive. Whenever it's negative, you will see the negative sign. So we have a negative divided by a positive. Boom, right here, right here. We know that our answer is supposed to be negative. This is where we have a lot of problems. And test writers know that. So the people who create assessments for you, they know that. So when you drop a sign, you automatically miss the answer. Your teachers can give you half credit, but an assessment cannot. So it's very important that you know these things up front because it's real easy. An answer choice. So the answer to this, 3 divided by 3 is 1, 6 divided by 3 is 2. So the answer is y equals 12, right? Negative 12. See how I made that mistake? That quick. That's what happens on the test. So your answer choices, let's say this is a multiple choice, you're going to have positive 12 and negative 12 as answer choices. What else? I don't know what other distractor analysis. That would take me way too long to develop what these answer choices are. The important part is they're going to have both of these there. And if you don't actually pay attention to your signs, then it's very possible you would pick the wrong one. Just like I made that mistake and wrote y equals 12. It happens. It happens. So don't trip on yourself. Or allow anyone to make you feel like you're not doing the right thing. Just pay a little bit more attention because it's real easy to drop those signs that way. I've been teaching, I got my degree in math in 2002. But I've been good at math for a very long time. And I still make those, I guess careless mistakes, but you're human, so it happens, and it's going to happen, so whatever. All right, so we're going to division. I'm going to keep the side work up as far as the little reference table we've needed to reference there. How many shirts do I have? I'm not spending a whole bunch of time on that. I am going to go to open word. Let's go to open word. All right, so we are going to division next. Division next. So division, you're going to see either let's go. X over Y. That can be representative of division, or the actual division symbol, or like that, 1/2. That also represents division. So if you had 12 over 6, you would simplify that to 2. So, okay, so those are ways that you can see division. And we're moving on to, who are we moving on to? Oh, we're moving on to open word. All right, so there was a day when my heart was broken from education, and so I was looking for a group of 2 students to serve, doing too much, because you don't have to do that. First of all, take some time to heal. Your heart is broken, take some time to heal. Anyway, so I worked with the teen ministry at the church at Open Word. But what what is most precious, even though I miss them, love them, I love them, we had so much fun. We had fun. So, okay, I'll go with a funny story. So a funny story is this. I worked with them like the end of a school year, through the summer to the beginning of a school year. So I saw the students come, break for summer, and then go back to school. So there was a young man who he just liked to play. He liked to play, and he liked to play too much. Okay, you play too much. So he and I would have banter because, like I said, I taught boys, so it's all good. It's cool. We playing, whatever. So this particular day, but he was also lazy. So he was a football player. He was a football player, right? So summer happens. He did not do his summer workouts. Okay, cool. He did not do his summer workouts. So, okay. School comes back in. Football season has, they prepping up, they ramping up, they now back. So he come in. So I already know what's going on. You didn't do your summer workouts. Workouts just started back. You done ripped your muscles and you can't walk. So he decides to start talking junk. I forget. I can't even tell you what he said. I don't remember what he said. I just remember talking junk. He, it's like, oh yeah, I'm a da-da-da-da. Okay, you word. So I said, I tell you what. If you do that, I just want you to know what I'm gonna do. I said, you see this? I'm gonna take this, and I'm gonna pop you right in the middle of your thigh. Not even hard. Just enough pressure to make you go to the floor because I already know what's going on in your thighs. You want to cry right now. You said you wanted to stay home from church. Mom, you know football just started. My legs hurt. Anyway, so it was hilarious because he shut up immediately and sat down. Exactly, boy, because you gonna fall. So he was funny. They were funny. Loved them. And I danced with the dance ministry. They did a play. She Wears Hope, I believe is what it's called. I never got to actually see the performance, but I really had so much fun, and I danced with a group of teenagers. I was the only 30-year-old, but we had a wonderful time. So that's why. Love them, precious. Let's go division. All right, division. Where are we? Division. Okay, so I want to do, I'm going to adjust because I know that I'm here, and if you're here, you're here, and if you're not, then this is for later anyway. So negative 4p, because I just wanted to give a random letter. So negative 4p equals negative 64, right? All right? So negative 4, so I'm going to follow the same process that I have been following. Identify what I see. I see multiplication. That ain't what I wanted to do. I gotta change the problem. Sorry, y'all. That ain't what I want to do. Let's change this to negative 16. Let me do something easy. Negative 12. And then let me do p over 4. Yeah. P over negative 4. Nope. Negative 4p. Alright. Boom. Alright. This deals with a lot of stuff, and I like that. So I had to change it because you didn't actually see division, and therefore it wasn't the problem that I wanted to model for you. So now we see division, all right? So we see division. So if we identify that we see division, then we know that we actually need to use multiplication. So boom, multiplication, remember multiplication, division, they undo each other. So division, I'm gonna use multiplication. Now the question is, so remember on the multiplication when I told you what we multiply by and what we divided by. Here's the thing, you have to identify what that is. So right now, technically, what you see is the division. I'll put that in another color. Well, you can see one of two things. So, because I know that there are advanced math learners out here, you see two things. So you either see multiplication, and I have to address it because this, remember, if there's no value there, there's a 1 there. So there's a 1p there. And then you have the negative. That is the same thing as negative 1/4 times p. Or, so some people didn't see multiplication. Some people saw division. And if you see division, that's fine. I just want you to make sure to keep the sign. So then you have p divided by negative 4, and that equals negative 12. Both of these, that equals negative 12. Both of these can be solved. We're taking this route. Because we said we saw division. So if we see division, then I just want to make sure that we're able to follow the path to multiplication. But technically, because it's written in fraction form like that, and anything written like that can also be written as the multiplication by a fraction, it's just we do not like fractions, so I'm not going to stress about it. We're going to use division. So if I see division, I see division by negative 4. That's what I need to clarify. All right, that means I'm going to multiply by negative 4. So again, something else is going to happen. So I've got p divided by negative 4 equals negative 12. So I'm going to multiply both sides of the equation. Multiply this times negative 4, multiply this times this side by negative 4, right? Boom. I don't need those parentheses, that dot, but multiplication. All right, so here's the thing. On this side of the equation, let me simplify the right side because it's easier. We got a negative times a negative. Boom, here we go. Negative times negative. Boom, here we go. Positive. So I know that's going to be a positive. 12 times 4 is 48. All right, so that equals 48. You don't have to write that positive, but I just want to be thorough. Now, here, you're going to multiply times the negative 4, which is the same thing as, that's why I added a cell. This is the same thing as negative 4 over 1 times p over negative 4. Okay? Anything. So once again, when you see a whole number, so whole numbers can be written as fractions. I'm so sorry, y'all. I'm not. Whole numbers are always the number, let's say 4 over 1. Over 1. We don't write it that way, but we can rewrite it that way because it doesn't actually change the value of the number, because 4 divided by 1 is still 1. So writing it by that just allows us to multiply it. So same thing, 20 is still 20 over 1. We only write it when we need it. So in this moment we need it because we need to be able to multiply across, because this is the same thing as -4 times p divided by -1 times 4 and -4. And remember how we said anything over itself is 1? So those two things cancel out. Those two things cancel out. Where I get the -1. See what I'm saying about that sign thing? It's not a game. Again, I got a degree in this. So if you're here, if you catch this, I don't want you to ever feel like it's real easy to either add a negative or it happens. So be careful. All right, because I just made a mistake, but that's all right. I got it. I caught it. I caught the mistake. There wasn't a negative there. I shouldn't have put that negative there. So boom, that took care of it, because now a negative divided by a negative is a positive. So now I have a positive 1, p equals 48, and that is the answer that I need. So p equals 48. So that is my final answer. Now that is single steps. Now we did single steps for a reason, right? Because then our next problem is double step. And I don't think I'm erasing all of this. I'm erasing all of this. Yeah, it's gotta go. All right, so now we're gonna go to multi-step. Just a few, maybe 1 or 2, if I'm not mistaken. And I didn't do parentheses on both sides of the equation. I'll come back and do something like that. That's a little more complicated for the day. We could do that, but I want to get through all of the things I have planned, and it is 12. So I've been going, I don't know, about an hour and a half now. So I just want to get everything. For solving multi-steps. Okay, solving multi-step equations. So this process is going to take everything that we've done up until this point. Everything we've done up until this point. All right. Oh, we got to go. All right, so because we are going to a new, I'm gonna put the 2x plus 6 equals 14. 2x. Ooh, yeah, because this is word, multi-step. And you know what? I'll challenge you on the next one. I'm gonna rewrite it so I can use parentheses. So, all right. Yeah, I'll challenge on the next one. We'll do parentheses. We're gonna keep this one relatively simple, and then we'll use parentheses. I won't do variables on both sides of the equations today. If that is needed, request it, and I'll put it up. But I should be getting a curriculum today, so the plan is to start rolling out lessons for the school year, and then I'll just do problem sets as I'm able to. So it won't be a lot of this in the beginning, because I really want to get instructional videos out, because my hope is that my instructional videos will support teachers' instruction. So they can either use the videos in their instructional lessons, or they can assign them for homework, which would be an outstanding way to flip the classroom without actually having to flip the classroom, if that makes sense. So it can be, let's say you find a student is struggling with solving equations. We're solving equations. Hey, sweetheart, I'm gonna assign this to you for homework. You can create a quiz. You can have them bring you the notes. There are several ways for you to use it if there are teachers who are here to supplement your instruction, even if it's not necessarily an approved site. Because if it really works for your students and the voice really works for them, then assign it for homework and have them bring the notes as your check, and then give them because that was one of my notes. That was a part of why my kids were successful. I paid them for notes. They hated it. They hated to write it. My hand hurt. My hand cramping. And so what? Love you. Not answer what. I wouldn't say it like that. But writing is a study skill. Recopying your notes helps you actually learn the math. You have to do the math to get better at doing math. So they had to take the notes. Every day I gave instruction. It wasn't every day, but when I gave instructional notes, their homework would be automatically recopy your notes in your own handwriting. And no, you may not photocopy it. It must be your handwriting twice, because I only say that because I've had somebody's girlfriend did their work for them, and then somebody sent me some photocopies. Please stop. You have to copy it yourself. But it's a study skill, so it's going to help you retain. And that helped them be successful. And period. You got to do it because I need you to be able to do it. We can't have fun activities if you don't know the math. So I can't send you to create and build, and we can't do those things if you don't have the foundational basis. So I need you to have the foundation so I can say, okay, now let's go build this. Let's go create this. I want you to make this. So the application comes from knowing the basic foundation. All right. Anyway, this shirt. This is because I am a member of a Change Her Squad. Change Her Squad. I go to Change Church, and I love them. I can't say that there's a funny story at this point. I just can say that I've begun to find my community, and I didn't have one. And so this is more epic than anything else. I'm finding my people, and I am so grateful. So just some of, I had some people I've had to reach back because, but I've reached out and they know who they are and I know who they are. But just with respect to the new connection, because I am like 10 toes down. Oh my God, I'm just saying. So change church, change her, all of that. And I went to a conference and I got the shirt because this is what I do. And this is what I do. If you notice, all these was cut by me because I really don't like regular shirts like that. So I love t-shirts, but I love to cut a t-shirt up. All right. So that's that. Don't have a funny story yet, but except I kind of started one of my preachers because I was in Uncommon Calling, one of the programs, Uncommon Calling, I think. No, it was Bible U. And I knew them, but they didn't necessarily know me by face. So I just came up, gave him a hug. He was like, oh man, it's great to see you. And he was just like, who is, oh right, you know me, but I don't know you. So it was one of those moments where it's just like, ooh, my bad, I forgot. I just kind of, so like, hey bro, it's been good to see you. What's up? And he was just like, hey, God bless you. I'm not a stalker, I promise. So we're doing solving multi-step equations. And this is going to be somewhat complicated because it takes, I built this on purpose. I started at a place on purpose because everything, okay, solving equations. So when you're solving an equation, it is easiest to start by clearing the addition or subtraction, okay? Easiest to clear plus or minus. Now, I liken this to taking off, like, okay, you know how you wear socks and shoes, right? So it is possible, because I messed around and said one day it was a boy, I said, you can't take off your sock without taking your shoe. You absolutely can. Taking your shoe off, you absolutely can. He spent the entire period getting his sock off without taking off his shoe. So it is possible. But it is much easier to take off your sock if you take off your shoe first. So that is what's going to happen. Can we deal with this multiplication? Yeah, but it's going to create fractions potentially. We don't like fractions, so don't go there. Deal with what's going to be easiest, because then if I have to divide, my final answer is going to be a fraction and I don't actually have to use it in the equation. Okay, so that's the why. So yes, please take off your shoe before taking off your sock. Can you do it? Yeah. But do you want to? No, we hate fractions. I don't, but most of my students were like, dude, please stop with the fractions. So let that be the last step. Let division be the last step. Okay, so we're gonna start. So our first thing is we're gonna start by clearing positive or negative. So I see plus. So boom, I see plus. Use minus, right? So I see plus 6. So I'm going to subtract 6 from each side of the equation. So let's start there. Now, remember I told you, it's nothing wrong with doing that. So I'm going to subtract 6 from each side of the equation. That's going to go to 0. Bring the 2x down. So 2x, we're not going to write that 0 because we said we're not going to do that. And then 14 minus 6 is 8. Okay, cool. So then at step 2, we've applied that. We're going to simplify. We simplified. We now have x equals 8. So that's the simplified version. Now we got to run it again though, because we have an x, so we need x equals something. We don't have that. Okay? So I see 2x equals 8. That means I see multiplication, if that makes sense, right? So I got a letter and a number beside each other. Remember we talked about that? We got a letter and a number beside each other. That means that's multiplication. So I'm going to use division. Okay, so I see the multiplication by 2. I'm going to divide by 2. All right? So hopefully I'm not going too fast. And so now that I've done that, now I actually have to do it. See, multiplication, use division. Got that line there. I'm going to divide both sides of the equation by 2. This simplifies. X equals 8 divided by 2 is 4. Final answer. Okay, for the last step, we simplify. Okay? All right, so hopefully that was not too fast. And again, please share with any teacher who may need resources, additional resources for instruction, any students who may need additional voices to listen to help them with mathematics. Okay, we talked about that. All right, so where are we going? We just did, all right. Remember I told you that we were doing another one. We're doing another one because I want to make sure to, so I'm gonna keep this framework. I'm gonna keep this. I'm gonna keep this because we don't know what we're using. And then I'm gonna erase this. And now we're gonna run one more of these because I want to make sure that we know how to use parentheses, and I'm going to change t-shirts. So we've got -3. So number one, I want us to keep having practice with these negatives, negative and positive values. And then x minus 1, distributive property. Remember we discussed distributive property, but we're also, so again, that's why I talked about all those things before now, because we're using them all now. Equals 18. So we're gonna do some, okay. Remember this? PEMDAS. Now, some of us don't know what is PEMDAS, or some of us know what is PEMDAS, but some of us know it as a different acronym, right? And so we want to make sure, because the reason why it's important now, which is why I did have to introduce it before, so I'm glad I did, is because it's totally relevant. But, there are 2 ways to solve this problem. Okay, I'm looking at my time. So, I'm changing shirts. Now, this one is not a school shirt. It's not a school shirt. But, again, there are things that are a part of the why, you know. So, I have 3 brothers, 2 living, no, 1 living, 2 passed, 2 deceased. This is one of the ones, right here. He attended Whitlock Flexible Learning Center. He passed from cancer. And he passed while I was actually working at Whitlock Flexible Learning Center. So going back to work was extremely difficult. And when I went back to work, I didn't actually tell the family what was going on, because it was a rip the Band-Aid off moment, if that makes sense. I was gonna have to go to work at some point. I knew he had cancer, and I knew the day was coming. I said no sadness, but it is what it is. That's what this is, because they supported me. I got this beautiful peace lily, and it was good to experience that again. So it was a work family type situation, because it was hard that day, and I had to do it the way it was done. And it was, why you didn't tell us? Because walking through the door took everything I had. Because it didn't matter what day I was going to do it, I still had to walk to the school where my dead brother, it is what it is, who passed from cancer. I saw you not at your best. I still had to go through that door of the place that you used to walk, and you will never walk again. So it was very difficult, but they were there for me. So again, Whitlock, Forest Park, we'll talk more about that later, but love. And for my brother right here, love. He's got babies out there. But yeah, so bird gang. Ha! All right, so let's solve this problem. So I may do two methods. Because where am I? I'm on solving equations. I didn't do polynomial in degrees. I don't know. We'll see. Because I want you to understand that there is two ways to solve this problem, and one way is easier than the other. This is what I would do in the classroom, and if you're here, then just laugh about it because you're not actually doing it. But I'm gonna do the hard way first, okay? So the hard way. All right. So if I do it the hard way, and then the acronym, please excuse my dear Aunt Sally. So some of us know, please excuse my dear Aunt Sally. Some of us know PEMDAS. All of it is just a way to remember the order of operations and how they're to be used. And the reason that's relevant now is because we have parentheses and we need to start there. And if we saw exponents, then that's what we would use next. So since we have parentheses, we need to resolve that first. All right, cool. So the hard way is I see distribution, okay? I see distribution, which also means multiplication. Okay, so that's what I need to see. So I'm going to use, so that's what I'm using. Multiplication first. So we got to run some circles on this. So that means negative 3 times x, distribute it, so pass it out, take that 3, pass it to everything in the parentheses, minus negative 3, we'll look at that double negative, times 1, right? And let that equal to 8/10. All right. So we have distributed the negative 3 to everything in the parentheses. There are only two things. Pass it that way, boom. Pass it this way, boom. And 18 ain't nothing on that other side, so we're not doing nothing else. All right, cool. So now, we know we simplify. So negative 3 times x is negative 3x. Negative times a positive, negative. Negative times a negative times a positive. So first, negative times a negative turns that to positive. 3 times 1 is 3. If that would have been another negative, then that's when it would have been negative. But the negative and the negative make that positive. And then we bring down the 18. So hopefully I'm not moving too fast. Now, if we don't see x equals, now we just don't have to have an x, but m equals, n equals, like positive 1 in front of it, we're not done. We got to go another round. What do I see? All right, now, this one looks like this example prior, right? So I see addition. So I see plus. So this is what I see now. Negative 3x plus 3 equals 18. I see plus. That's the first thing I need to deal with. I'm going to use minus. So plus 3, subtract 3. Bet. All right. Plus 3, draw my line. Minus 3, minus 3. All right, cool. That goes to 0. Bring the negative 3x down. 3 minus 3 is 0. Negative 18 minus 3. 18 minus 3. You see why I did it again? I'm just saying I'm not doing it on purpose. This is just what my brain is doing because I'm on one. So 18 minus 3 is 15. All right, cool. But does it look like x equals? No. So we simplified, but because it doesn't look like, need x equals something. If it doesn't look like that, we got to go one more round. What do I see? I now see negative 3x equals 15. So I see multiplication. And now I use division. So hopefully you were there with me. So I see the multiplication by negative 3. So I'm going to divide by negative 3. So you see how it rolls when you're solving multi-steps. You got to start with what do I see? How do I simplify? Where do I start? I see parentheses. I got to start there. Get rid of them. Do what's necessary to get rid of them. I hate to say it. That sounds bad, but that's what you're doing. Get rid of them. Simplify. Boom. Now what do I see? If it doesn't look like this, we got to go another round. Simplify. Now what do I see? If it doesn't look like this, we got to go another round. Okay? Boom. All right. So we're divided by negative 3. Divided by negative 3. That simplifies. Anything over itself simplifies to 1. I'm writing it just so, again, somebody may come on. This is a fundraiser. If you're just getting here, Ms. Logan is trying to build content for all students with students of color in mind. Because I think my voice matters. So 5 divided by negative 3 is negative 5. So yes, I'm running a GoFundMe for supplies so that I can really get my classroom up and rolling. And there's also Cash App if you would like to donate. If you can't, no worries. If you can, I'd appreciate it. All right, so we now know that our answer, because if we had to run another round, then that means we got to simplify again, okay? All right, so at this point, we are now at our final answer. That was the hard way. So we're going to do that again. Where's my towel? What I do with it? Okay, so I can't find it. I'm going to use a shirt. Oh, no, I don't want to use a shirt because just in case I got to do this again. There's a towel. All right, so now we're going to do the easy way. So I'm going to erase all of this. I'm not going to rewrite the problem because we're going to use the same problem. I'm just going to, this is the loveliness about boards, and that's why I want to project it, because I can, like, when it comes to like parabolas and things like that, the quadratic function is so great to just project it onto a board and go from there. All right, let's see. All right, I don't know. I just know that there's an easier way. So right now I'm not sure what's going on. So we'll get there. All right, so now we're going to talk about the easier way. I want to say easier way. All right, so the first way I feel like is harder than this way because I actually didn't see it until I built the equation because I adjusted it so we would see parentheses. But the easiest way, you're still going to have to deal with these parentheses first, right? So I got to figure out how to deal with that. But if I see that this number is multiplied by this is called a binomial. We'll talk about that next because I'm going to polynomials. But by what's in the parentheses, then I see multiplication. So the easiest way is to see the multiplication by the parentheses, okay? So I'm going to see the multiplication, and I'm going to use, not that, I'm going to use division. Now, let me show you what that looks like. So I see -3 x minus 1 equals 18. I can take the entire, so multiplication by -3, division by -3, all right? So I'm going to take the entire left side. Remember, this is the equation, the equal sign. The entire left side, divide by -3. The right side, divide by -3. Anything over itself simplifies to 1. So when you do that, this piece is gone. But anyway, okay, I'm moving too fast. So, oh yeah, don't mind. No, we started with division. So we're divided by -3. Boom, that simplifies to 1. So I'm now left with x minus 1 equals 18 divided by -3 is -6. Right? Right. So once I do that, I simplify. I got x minus 1 equals -6. So now I see x minus 1 equals -6. And the operation that I see that I need to deal with is this subtraction, right? So I see subtraction. We had the -1. I use addition. So we're going to add 1 to each side of the equation. Now, because we chose to do it that way, this is going to eliminate that extra round of having to simplify, because once I, remember that's the equal sign, once I add the 1 to each side, right? Boom, boom. This turns to x, and then that's that -5, and we're at the answer. So identifying that that's multiplication up front and simplifying it out does cut out a step in the process. But if you notice, both of them got to the same answer, so it really doesn't matter which route you take. Just follow the correct mathematical procedures and you'll be fine. All right, so now let's talk about polynomials and what even is that, okay? Like, what is a polynomial, Miss Logan? You're tripping. I don't need polynomial. Who says that? Who does that? All right, mathematics people, scientists. All right, so I've been dancing around polynomials for a little while. And since we going, all right. So we got some polynomial things we just need to discuss. Again, algebraic knowledge. Hopefully, I will be able to take this video and cut it up without having to redo it. I don't want to redo it. This is a lot. This is a lot, but if I have to, I will. Especially once YouTube, because if I get it on YouTube, that's the trick. If I get it on YouTube, then all I have to do is download it later, and I could even pay someone to edit it. So we'll see. We'll see. Yeah, this is gonna be the last one because I think I've talked about everybody. Oh, except for DHS. Ooh, DHS. That's next. And then we're going to go to the final, and that's just where I will be for whatever's next, because I need to talk about parabolas, the quadratic function. Oh no, I'm lying. I hadn't hit geometry for real. I mean, I have, because you have to apply with algebra. We haven't talked about points, point slope, graphing a line, graphing a point. So no, that will be, all of that's going to be after I change. So I'll talk about Dorman. Now, this shirt is for my twin. So again, I know that, but if you notice, there's reason. I got beef with cancer a little bit. I know that we are where we are, but I've just lost a lot of loved ones to cancer. So this was my twin, Ian Reed, my little big bro. He was 6'5", but he was a year and a half younger than me. So that's why he was my little big bro. And I used to, oh my God, he used to get on my nerves. If you have little siblings, then you understand. But I loved my brother, and he passed. He actually passed a couple months after I came from Atlanta to South Carolina. So I think that was God's gift to me, to be able to really just spend his last days with him. The last conversation we had before he kind of lost real consciousness in his battle with cancer was not a good one. I was very angry, and I regret that. But I love my brother, and I've forgiven myself, and he's still my twin. He'll always be my twin. We used to sing together. We would do Lauryn Hill's Killing Me Softly. I would sing, and he would, One Time. And I drove all the way from where I was in Atlanta to Orangeburg when he attended South Carolina State, and we performed at some performance, because he just was like, yo, I need you to come sing with me. So that's who he was to me. That's my guy. I miss him dearly. He has 3 children here left, and all of this is for them. I haven't talked to mom yet to let her know, because I think she has a 10th grader. My oldest niece, I think, is going to the 10th grade, if I'm not mistaken. So she'll be tremendously helped with this geometry as well. So it's for every student. It's not just for my family, and that's why it's YouTube and YouTube only. Not YouTube only, because we on IG, we on YouTube, we on X, we on TikTok. All right, let's go. We are going to polynomials. Okay, so I'm going to do my best to try to get this in a reasonable amount of time. It is 12:30, people. I have been going since like 10:30-ish. Oh, we talking about test prep. Okay, so a polynomial is, I think it's an algebraic expression. If I'm wrong, I will come back and correct. An algebraic expression comprised of terms separated by operations. Now, this may not be exact, and if I need to adjust as I will, because like I said, I don't have my book in front of me. This is just off the cuff right now, off of everything I've experienced. And we're going to talk about examples. So we have a, it can be a variable, a constant, and what that means is a number. That just means a number. So 7, 0, not 0, -5, a number. What that means is a value without a variable. Okay, that's what a constant is. So it could be or both, like 6x, 26, 6x. Okay, so this is gonna be x, y. This is gonna be 7, 10. This is gonna be a combination of the two. Okay, but they're gonna be separated by operations. So a monomial is not, because it is one term, and let's say that is 3x, okay? If it were 6, that would be one term. A binomial is 2 terms, so that's going to be 3x squared plus 4. Does it have to be 3x squared? No, it could be or -1/2 x plus 5. So both of those are binomials. Why? Because they have two terms. By two, right? Okay, so this is a polynomial with two terms. Monomial, a polynomial with one term. Another one that we use very often is a trinomial. And hopefully if you're with me, you would know that because tri, that prefix means three. So we're talking about three terms, right? So that's going to be your negative 5x squared plus 3xy plus 10. All right, we have 1, 2, 3 terms. So that is going to be a trinomial. All right. Now, the reason why that's important is because combining like terms, you're going to be dealing with the concept of needing to understand what a polynomial is, what kind of polynomial. You're going to be using those in the closed operation. So that is something that I saw in the geometry curriculum. So this one here, again, this is algebra and geometry. It really just depends on what part of the year you're in. And like I told you about geometry, even when you're opposite interior angles, find the degrees inside of a quadrilateral. All of these things are applied through algebra. So you're going to have to combine like terms. You're going to have to use the distributive property. You're going to have to do all these things in order to actually perform the standard. All right, now term. Not term, degree. Degree. All right, so when you're dealing with polynomials, one of the other things that are on the end of course test that you need to know is the degree, and there are two things. So this is still under the header of polynomials, right? So you have the degree of the term. Okay. Okay. All right, so you have the degree of the term. And for this, we're going to use the example of, did I write one? I hope so. I did not, so let's see if I can make this work. I want to do 4x squared y plus 3xy minus 7xy cubed plus 4. No, plus 8m, no m's, 8x minus 10. Very good. All right. Now, let me make sure. Yeah, okay. All right, let's discuss this. So you have first, degree of the term. So that is going to be the exponent value or the sum of the exponent value by term. Okay. All right. So we talked about terms, right? So what I'm going to do is I'm going to do a little color coding first. So if we know we have 1, 2, 3, 4, 5 terms. Now on purpose, I made their degrees separate. Okay? On purpose. So we have 5 terms. Now, the way you find the degree of a term, so let's look at term 1. So this is term number 1. So term 1 is 4x squared y. The way you find the degree is to identify all exponents. Now, that may not make sense right now because you're like, well, what are you talking about? So can I see all the exponents? Well, 4 and, it's not all exponents because we're only talking about the exponents for variables. Exponent value for variables. And you know what? Okay. And the reason why I identified that, that's not necessarily in the definition because there is another thing that If we're doing it, we're doing it. When you see a whole number, technically, if we're talking about degree, then there is an exponent there, or you can have an exponent there, because any x to the 0 or any variable to the 0 is equal to 1, like 1,000. So we're not talking about exponential values right now, not yet, we will, but when you raise anything to the power of 0, then it's 1, okay? So the reason why we never write that is because it's there, but that's also why we don't consider the degree. So it's gonna be like, oh, but Miss Logan, there's an exponent on that 1. You said that if it's a number, there's always an exponent. It is, but we're actually talking about degree, which means we're looking at the variable. So if there were a variable there, it would be x to the 0. So you're not considering the variables on the whole numbers in this moment. You're just considering the variables on the degrees, the exponent on the variable. So there is nothing sitting there. So that's why we don't actually consider that one. So we're only talking about x's. So if it's not there, you only consider these when you're finding the degree, okay? All right, so from that perspective, I'm not even paying attention to that. This is what matters. So the degree for this term is going to be 2 plus 1, which equals 3 for that term. Now, from that, I'm going to put that, and then we're going to talk about, I'm just color coding. So, okay, boom. The degree of term number 1 is 3. 2 plus 1 equals 3. So now I feel like we can find the degree of each of the terms. So that was term 1. You know what? Just to be consistent. So term 2, so this is term 2, 3, 4, 5. I just want to be clear. Okay, so term 2, we have 3xy. So that same thing as 3. We're not going to deal with it. We know that. But x1, y1. So then the degree is going to be 1 plus 1 or 2. We okay? I hope I'm not moving too fast. We've got term 3. All right, term 3. We have negative 7xy cubed, or to the 3rd power. So I'm going to use cubed and 3rd power interchangeably. We know at this point, we're not dealing with that 7. We can write it down just to be consistent. But we have an x, there's no number, there's a 1 there. Y to the 3. So the degree for that term is 1 plus 3 or 4. So the degree for the 3rd term is 4. All right, let's jump to term 4. Yeah, term 4. Term 4. Sorry, let's be consistent in practice. And again, I hope that you're able to hear me clearly. Because, yeah, we're trying to get this done. All right, just give me a moment. Sorry, y'all. My battery was fully charged. Oh no, that ain't gonna work. All right, y'all, I had to give me a minute. Not a full minute. I need to, there we go. All right, good. All right. I need to go get a charger for my phone. I'll be right back. Okay, I'm back. All right. Yeah, what are we talking about? All right, I'm back. Where were we? Term 4. All right, so term 4 is 8x. We know we're not dealing with that 8. We don't have to. X to the 0. So that means x to the 1. So the degree is 1. And then finally, love it. All right, finally, term 5. And yes, just because it doesn't have a variable, it's still a term. So term 5 is -10. Remember, that's the same thing as -10, not dealing with it, but x to the 0. So the term of that degree is 0. All right, so that's how you find degree of a term. Now, and that was important because you cannot find the degree of the polynomial without knowing how to find the degree of the term. All right, so I'm erasing that. We are going to move to degree of the polynomial. Now, after finding the degree of the term, it's easy. And I can say that because you'll see in a second. So, erase that. Degree of the polynomial. I'm keeping that example here. We are not doing another example on this. We're just not. All right, so degree of the polynomial, which follows. And that is simply going to be the degree of the highest term, if that makes sense. I don't think I said that right. I'm going to put an asterisk there. I don't think I said that right. So it is going to be the highest degree of any term. Okay, I feel like that's a better definition. Now, what does that mean? What does that mean? What does that mean? What does that mean? If you look at your terms, first term is 3, second term is 2, third term is 4, fourth term is 1, 5th term is 0. So then the degree of the term is 4. So it's just the highest one. So once you determine what the degree of each term is, and you do have to consider both of the variables. And so that's why I did an example that was kind of complicated, because what will happen is, especially here, sometimes people will hit that one with a 3 because they'll forget that 1, or they won't consider that you have to add both of the degrees of the different variables. So I wanted to show all of that in one example. And hopefully you were with me. Because again, all these things kind of, if you notice, as I think I've done a relatively good job of building and showing how that, the lower pieces, not lower, but the initial groundwork is necessary to just do the other stuff. And all of this is super necessary in geometry, because I taught geometry and I had to teach algebra in order to teach geometry. And so it got me in trouble many times because I wouldn't be on the scope and sequence. And so it would seem like I wasn't doing my job. And it was never that. It was that the students didn't have the mathematical foundation to do the work for the geometry. And so I would have to do many lessons in algebra just to make sure that they could actually do the work, because geometry is applied with algebra. So even if you're teaching geometry, you're teaching algebra. So it's best, if you're teaching geometry, to have an algebraic resources. You can say, okay, I see that you're having some issues struggling with solving equations. I'm going to refer you to this for homework to supplement. That's kind of what the USA Test Prep is about. But USA Test Prep just kind of, it gives you problems to work on. So it standardizes the work for the student. So you absolutely positively get to give them work that is standards based. So it's addressing what they need, but it doesn't give explanation. So it's only helpful to the student who understands that standard. It doesn't actually teach the standard, so it doesn't supplement what you need supplemented for the child. You need them to understand, then you need them to go practice. Because what I also found, which is why I changed my homework process, is that students were going home and practicing the mistakes. So go home and do your work. Oh, okay, cool. Go home and practice these problems. But if you make a mistake and you're doing it wrong, then all you do is repeat the mistake. So then you've learned the mistake. That's why I was like, no, go home and copy my notes, and then we'll do the work in here, and I'll correct the process while I can see you. Because now I can send you off to some group work, partner work, and I can walk the classroom and make sure that everybody's doing what they're supposed to be doing. Or if they're stuck, I can kind of sit with a group because I know that this group is functional. Or I can partner students like, oh, you know what, y'all got it? Hey, can you come over here and sit with this group? I'm going to sit with these kids, and I'm going to give them another mini lesson because they need more time. And I just want to help with that. So that's why I'm asking for support in the building. So that's why this is a fundraiser. And if you notice, I've been going for like 2 hours. But again, FPHS, Saturday school, test prep, it was a go. Now this one is Dorman High School. So this is my high school alma mater. I was in student government my senior year. I did not actually, I put my name on the ballot. Like I was just like, oh, that'd be fun. So I interviewed and I went, but I did not actually like, hey, vote for me. I didn't even know that I was supposed to do that. So it was cool. I had a good experience at Dorman. And so, other than that, that was epic. It just was like, how did you make SGA and you didn't actually do anything, put your name? I just talked too much. So people saw my name and was like, hey, yeah, I'll vote for her. That's how that happened. All right, so, but yes, my name on it. So high school. All right, so we talked about degree, we talked about term. Oh, what's next? Okay. Next, multiplying polynomials. Okay, y'all. Multiplying polynomials. So, I'm going to teach two methods. I'm not going to use the same problem. I'm going to use the first one. I'm going to use a monomial and a trinomial. Okay. So why? Because I want to teach the FOIL method and I just don't want to spend a whole bunch of time in it. Now the box method can be used with any polynomials. So first one, we're going to do the box method. All right. So our problem is going to be, and when you see box method, I want you to think distributive property. Because in essence, that's all it is, but the boxes help you organize your thoughts. That's what it does. But it's really just a distributive property. So we're going to take, I'm going to do 6x times 3x plus 6, 3x plus 6 plus 4y. Is that what I want? That is what I want. All right, so in the box method, again, think distribution. So what's happening is I'm going to distribute that 6x to everything in the parentheses, right? So it's like a 6x times this, 6x times this, 6x times this. So what happens is, if I have a trinomial, that's the box that I'm going to build, right? So I've got 3 boxes. Well, you build the box based upon, so this is a monomial, so it should be 1 on this side by 3 on this side. Okay? So that's how you build your box. And it's 1 because it's a monomial, 3 because it's a trinomial. Okay? So on the box, you're going to put the 6x on this side to represent the monomial. And then you're going to put the 3x, the 6, so 3x represents the trinomial, the 6 represents the second part of the trinomial, and the 4y, and the 4y represents the last part. So now we're going to, I'm going to extend this since I'm going to write in the box a little bit. All right, now, remember, now we're going to distribute it, okay? So, all right, so I got the 6x, so you multiply the corners of the box, all right? So the first thing we did was draw a box per dimensions. I know, I hope you understand that. Oh my goodness, I'm using this. So 1 by 3. You can think sports terms, 1 to 3. Whatever is going to help you build the shape based upon that's a monomial times a trinomial, that's why. So that's the first thing we did. First, draw our box based upon the dimension. Second thing, we want to put values on the correct side of the box. All right, so that's why we put the 6x on the left, because it was 1, and the 3x on the top because it was 3. I mean the 3x, 6, and 4. All right, boom. Oh, and consider sign. At this point, we all plus as far as that's concerned. Should do some subtraction in there. All right, don't be mad at me. Minus. We need some minus. Gotta have those different signs. All right, cool. All right, so what happens though? So now that we put the values on the side, now we are going to multiply the sides of the boxes. So third, multiply the sides of the boxes. All right, cool. So for this one, now if it helps you, if it helps you, some of us need to do 3x, 6, and negative 4y, and then we also need to put the 6x on the other side so we know what's on the sides of the boxes. If that's what you have to do what you have to do to make math easier, okay? That's what I do. All right, so on this box, you multiply the sides. So on the side, I have a 6x, and on the top, I have a 3x. You don't write it twice because it's like a picture frame, length times width. That's what we're talking about, length times width, okay? Length times width, or length times width. I'm not sure which, but multiply the sides. All right, cool. Now, in this box, the top is a 6, or let's do the side. The side is still a 6x times the top is a 6. So that's what will ultimately go in there. Same thing here, side is a 6x. So remember we were distributing that 6x, right? Boom, put it in there. And then the top of that is negative 4y. All right, perfect. We have now determined what needs to be multiplied. So step 4, multiply and simplify. Okay, so we got everything in the box. Now, remember we talked about those rules. That's where those rules come in. We got some like variables here, so we're going to have to add those exponents. We do not have like variables, so we don't have to add them, but we are going to have to multiply the numbers. So everywhere we see numbers, we got to multiply them. Here we got some unlike variables, so all we have to do is rewrite. Okay, so I know this is a lot of stuff that we talked about, so if you're just now joining us, these are things that are at the beginning of the video. All right, so 6 times 3 is, what is it? 6 times 6 is, no, 6 times 2 is 12, times 3 is 18. So 18, x times 1 times x times 1 is x to the 1 plus 1. We're going to go slow. Plus, positive 6x times 6 is positive 12x. Now, we got a positive 6x and a negative 4y. Positive times negative is a negative. 4 times 6 is 24. And x times y is xy. Those are not alike. We rewrite. So there was a chart that was created. It was great. I'm going to have to make it digital. I mean, like, yeah, make it for y'all. But anyway, where you know what to do when you're multiplying variables, so on and such forth. So on and so forth. So we simplify this again, though, because we have 18 instead of x to the 1.1, 1 plus 1, we want to do x squared. Now, at which point you do the first simplification, you go back and look, can you combine like terms? If the answer to that is no, you're done. If the answer to that is yes, you combine like terms, you check again. And that's where that is the component where we kind of trip, because we're going to feel like, I got to do something else. It shouldn't have 3 parts. Yes, it should. They're not like terms, you know? So I got an x squared. I don't have another x squared term. Can't add it to anything else. I got an x to the 1. It's not written, but we know that's x to the 1. We don't have another x to the 1. We can't combine it with anything else. And this is an xy. So all 3 of these are different. If they're different, this is our final answer. There's nothing else we can do. So the only variation is if, let's say we were on a test and maybe they had the answers written like this. The signs would be the same, the order may be different, but it would still be 18x squared written somewhere. Now they're probably going to write it descending order by the x value or whichever exponent they have, which is why it would probably be written like this, because it would be x to the 2, x to the 1, and then the next term. But just know that the sign, it matters that the negative 24 needs to be with the negative 24xy. So if it's switched around, pay attention to that. The people who write tests make the mistakes that you might make on purpose. All right, now we're going to do a different method for the FOIL because it's binomials. And the reason why we did the box method, and you can use the distributive property without using the boxes, but that helps a lot of students organize, and so that's why I did that. You can do that. After I do this, I am going to take a mini break. I'm not going to stop the stream. I'm just going to wash my face, grab a bite to eat, and change clothes so that I can do the last push in the leader outfit. And I'll tell a story. I already told, the why, Melvin, but I haven't told, how that particular fit came to be. But we wanted to do FOIL method. Oh, got to do FOIL. So here's the thing to avoid. So FOIL is wonderful when you know it, but it is limited. You can, only for 2x2s or binomials. So lovely method, except you can only use it on something that looks like this. So for example, the monomial times the trinomial that we just did, FOIL doesn't work. So that's why it's necessary to know more than one method, because if you're dealing with anything other than binomials, FOIL does not work. Just letting you know. All right, so FOIL is an acronym. First, outer, inner, last. FOIL, okay? All right, so that's where that comes from. So that's why the FOIL method, when people talk about it, we talk about multiplying binomials. Always, because we can only multiply binomials with the FOIL method. But it is very convenient and it's very helpful when you do know it. Because a lot of what, especially for parabolas, like when we actually start talking about that, the plan was to talk about that. I don't know, that's really heavy. And we'll see. Because I am at the point where I'm about to do points and point slope. And so we'll just see. Because that could be a great place, because that's going to be the 13th and the 14th concept that I'll be talking about at this point. And that's a pretty strong start to the school year. But the parabola is heavy, and the last time I taught algebra, we actually started there, so it may be important to do it today. But let's go with FOIL, and let's go with first. So what that means is you multiply the first terms first. So this is, now what this is, let me give you another color. This is y, the order that you multiply. That's what this is telling you. So if you can remember that, like this is telling you the order that you multiply the value, so the first. So that's representative of the first term. So multiply the first terms in each set of parentheses. So first terms. Sorry, y'all. So the first term in the first one is 3x. The first term in the second one is 2x. Now I'm just writing it so you know what's up. So that's going to give me 3x times 2x. Now, plus, we're going to fill these buckets. Now we're going to fill buckets, buckets, buckets. So this is going to be our F, O, I, L. All right? Yep, we're doing it like that. All right, so now that we've done that, and I'm using blue, I'm going to erase that. And we're going to have the outer terms. Okay? So now we go back to our parentheses, right? So which ones represent the outermost values? So the outermost values are 4 and -6. So you're going to multiply those. So 4 times -6. Oh, that is wrong. Oh, that's wrong, y'all. Oh, I'm so sorry. This is the outer. That's the outer. Sorry. The like terms didn't work out. That's how I knew. So that's going to be 3x times -6. Cool. So first, outer. So that's going to be 3x times -6. All right, inner. So this is going to be inner terms. Inner terms. All right, so for us, that's going to be that 4 and that 2x. I hope I hope it's not doing too much. So the inner terms are the 4 times the 2x. So I'm hitting here, 4 times 2x. I know I'm doing a lot of writing, but hopefully it's just, I know, I'm sorry. And then the last terms. So I'm going to boom, boom. And the last ones. So last terms are 4 times -6. We're going to put that in this bucket, 4 times -6. All right, so we have now multiplied everything by everything. So step 1, apply FOIL. 1. Apply. FOIL. 2. Simplify. All right, simplify. So we know some things at this point. We've been together for some hours now. We know some things. We know that 3x times 2x, 3 to the x, that there's a 1 there. We're going to add those exponents. So if you're just joining us, we multiply the numbers and we add the exponents of the like values, right? Same here. We multiply the numbers. So 3 times -6 times x. Here is written in a simple way. And then here. Now, I just wanted to make sure that we understood what's happening, okay? So that's why I wrote that out. Would I always do this? No, but in test prep, I would, because I don't know who got what, because I may not even be teaching all of my students, so I can't assume that they know everything that I've taught. So I would go this way with test prep, just to make sure that we're covering all of our bases. All right, so 3 times 2 is 6. X to the 1 plus 1 is x squared. 3 times -6 is -18. Right now, I'm going to leave the plus minus. We'll come back and fix it later. 4 times 2 is 8x and plus -24. Now, what that means, we don't keep the plus negatives, but we got some things going on, so it doesn't make sense to simplify it right now. Because if you notice, we got an x term here and an x term here. We need to do a new process. Not a new process, something we've already talked about, which is combine like terms. Okay? So once we simplify, you can almost bet. Ain't no almost bet. Every time, after you apply for it, you're going to simplify and then combine like terms. That's the nature of it. So you're going to take 2 binomials to a trinomial every time. Okay, I'm lying. Not every time. Not every time, because you've got the product of a sum and difference. And the middle term goes to 0. So not every time. But most of the time, you'll end up with a trinomial. But so what has to happen here is 6x squared comes down. Here, you have -18 plus 8. That is your x term. So this is your middle term is going to be where you end up simplifying almost always. Again, I told you I don't want to make too many generalizations because I might make a mistake and I don't want to do that. And then we're going to rewrite that. Now, we're going to rewrite this plus negative because you're never going to see that for the most part. Remember, a positive times a negative is a negative, so we're going to write that and we're going to simplify that. So after we combine like terms, we're going to hit you with another step of simplify. So simplify everything that can be simplified. 6x, so that came down. 6x cannot be simplified anymore. We have no other x squared, 6x squared, excuse me. 6x squared cannot be simplified. No more x squared terms. All right, cool. -18 plus 8 is -10x. And since we have to go one more round of simplification for this, because anytime you got a plus negative, we're going to simplify that to just subtraction. So, as needed is where we're going with that. Because some of you will not have to simplify to this step. Some of you will not have to do this step. Some of you are going to be able to go from this step to this step or from this step, because what happens here, we take the plus minus to a minus. We take the plus minus to a minus. And this is our middle step. Many of you are going to be able to go from here to here to here. And by the time you get it, like if you practice this, then you will be able to like kind of, like you may not, some of these steps, like what I did in class is we would take this and we would go ahead and do the 6x squared. This would be the -18x. This would be the 8x. And this would be the -24, and we would take this and line it up. So we've already done the work because we worked it, but just as far as in the classroom, when I'm teaching it, because of course I'm teaching it with a different level of instruction, where I'm not having to fill in all these gaps because I didn't teach everything at one time. But yes, what we would do is we would build that out with the problem, and then we would take that, line it up. So it's 6x squared. We would go -18x. Plus 8x minus 24, and we would simplify from there. From there, you would go to combine like terms and then simplify. So just classroom-wise, I would build it over here as our sidewalk. We would go ahead and We would go ahead and multiply through, and then we would be able to go straight from here to, all right, let's combine like terms. But that's just that. All right, so I'm going to take about, I'm going to take as much time to change clothes. I'll be honest with you. So if you need a break, I need a break. I'm not going to take long though, because I don't know. Right now I've got ordered pairs, lines, and parabolas. That parabola, I got to do it. All right. We're going to change clothes, get into something more comfortable. I'm lying. Get into something. I'm getting into my principal gear. So, just a little bit of context. I'm going to hit you with an I'll be right back. I don't even want to eat. I'll be right back. I am going to change clothes. And I'm not going to stop the video. I'm not going to stop the live. I'm probably just going to bite my PB&J because I'm actually still relatively geeked. And I got to take somebody to work a little bit later. So I had to drop somebody off and I got to take somebody to work. So we're going to do this relatively quickly with hopes that I can get through parabolas because I set my intention and I intend to keep doing it. So I'm going to move as expeditiously as possible, but I am taking a short break. So it'll probably be about 10 minutes or so. Just enough time to get changed really, because I'm ready to finish. I'm in that test prep mode. So when you're in that test prep mode, it's a level of energy that's just like, yo, I'm a home one, let's go. We got 3 more concepts really, and it ain't 3, it's more than 3, but I'm ready. So I did the prep work, like I'm geeked. So know that I have a desire to reach my goal, which is all the way through the parabola and the parts. And this one's for Victor, because that was my baby. Because again, he hit me with is this a man or is this a man? And I was like, why no student ever do it like that? Because that makes it so much easier to learn. So I do feel like I want to talk about parabolas. So I'm going to change as quickly as possible so I can get back, so I can get done, because I got some things that I need to do. Because I'm definitely going to breathe after this. So, Mrs. Space, I feel like you're the only one here. I'll be back. But it might be more than you. I just know that I'll be back. Give me a minute. Hey, we back. So, we back. Now, let me get it together. If you stepped away, I want to give you a minute before I start talking, because one thing I'm not going to do is stay in this coat. So, I led a school. First of all, I don't know how I feel about it, but anyway, Throwback Thursday is one of my favorite days of the year. Whenever we can get it in. And as a teacher, I was that teacher. So I was the one who dressed up. We was gonna find a way. I danced with my dancers at some point. We'll talk about that. We did a skit for the kids, like I was that teacher. So I was one of those teachers. I wasn't the only one. I was one of those teachers. So when I led a building, this is one of the ways that I lead, because I want you to have fun. Like, we're here because we want to have fun. We want to learn, but we also want to enjoy what we're doing. So every year, outdress me. I'm actually not pleased with my makeup, but I also didn't want to take a whole bunch of time, so I'm just going to be honest, full transparency. But I go hard on Throwback Thursday, because I want the students to participate. So I'm bigging them up the whole time, like, all clear. The year I did this one, because this jacket I've had since '98. Oh, this is not right. But anyway, this jacket I've had since '98. Ish, when I was in college. There was a Goodwill by Spelman College, and somebody, $20. Stop playing. It's leather. Stop playing. But anyway, I did get outdressed that year. One person looked just like the dude from Big Bang Theory. I forgot his name, but like, he just resembled the guy. So he had on the shirt, so it was exact. And then there was a group of girls. One of the girls, we had beef. We didn't have beef. She didn't like me, and we had to deal with that, because it was just like, yo, homie, you don't even know me to not like me. You giving me all this attitude. You just met me. Let me at least give you a bad impression before you give me that attitude. But she didn't. We did come to a place of good, and she and her friends did TLC, and they absolutely, as a group, they outdressed me. So, and this is the fit. Two things. Melvis then came to me the next day, because he was absent the day I wore this, and was like, yeah, I heard you look good yesterday. Yo, Melvis, you say that to your friends and not to your principal. I'm just saying, we should have boundaries, sweetheart, boundaries. You make even if you think that, you're not supposed to be like, yo, I heard you look good. Wait, I'm your principal. Stop. So it's like, Anyway, but the other funny thing, so this is a funny, I'm taking off this jacket because I'm already starting to sweat. I have hyperhidrosis. We'll talk about it. I sweat a lot, so this is why you don't see me with sleeves. I'm sorry, I used to get in trouble. Well, I didn't get in trouble, but it was a problem. I had a supervisor who did not like females to not wear sleeves to work, and I'm like, yo, homie, I'm in the 1% to 2% people who have, and I was a leader at the time, and I lay it better. Anyway, I'm sorry, that's disrespectful. Facts. Anywho, I'm back. I'm hot, but I will forget. So in a moment, I'm gonna forget that I have this costume on. I'm gonna forget that I have on a wig. I'm gonna forget that it's hot. I might even take the wig off because it's hot. Anyway, I will forget that I have this look on, and I'll be walking through the school or doing whatever, my job, and it's just like, oh yeah. If you hadn't seen me, then it can be like surprising, because when I can really go hard, then I really look like a full transformation. And one of the teachers who had not seen me in the day saw me at around lunchtime, and it was really funny, not because the person cussed, but it was because they were a preacher and they cussed, and we feel some type of way about that, but it just was what it was. But the person saw me for the first time, and they said sugar honey iced tea, but they didn't spill it out because they had not, my look took them by surprise. So it was really funny, because I made the preacher cuss, but I couldn't say it right then, because number one, I was at work and that was unprofessional, and number two, it was just unprofessional. So I just laughed about it later. So it was great, because he was like, oh, hold up, Pastor so-and-so. Anyway, he wasn't acting as pastor in that role. He was acting as a teacher. So, and, cursing someone out and cursing as a form of expression as a principal in a non-traditional setting that is the alternative school, and this is where people sent the kids that got in trouble. So I actually can't be like, I'm gonna kick you out, I'm gonna send you. I am the alternative school. I couldn't write every student up for cussing. I would have suspended everybody. I would have suspended some teachers if that's the case. So I could not do that. So I had to determine, were you cursing my teacher out, were you disrespecting them, or were you cursing as a form of expression and they heard you cursing, like you stubbed your toe and you said, oh, well, that's different than saying F you, So I couldn't suspend every child for cussing. And when I'm seeing how they engage with their parents, some of them got it honest. So yeah, and the wig ain't gonna work because it's too hot. So we're gonna change all that in a second. I got a ribbon, it may not work. But we are on back to this math because we just got to a strong, and again, this is still algebra. This is still algebra. And it's relative, it's relatable. So we're gonna start with, okay, let's start with ordered pairs. So I need to go down it's 120. All right, so I'm on like 10, 20, 11, 20, 12, 21, 23 hours. Ooh, Space, you still here? Surely you got a snack or a nap or something? Anyway, ordered pairs. So these are X, Y values. So your X is going to represent your X values. And this is also going to be your domain, okay? The domain of your function, of the function. I'm going to flesh it out. We're going to work it out, okay? So then the Y is going to be your Y value or use. It depends on how many numbers we have. Right now we're just talking about what is an ordered pair. What is an ordered pair? What is that? And then this is going to be your range of the function. Okay, so the X value relates to your X term or your X part, and we'll talk about that in a second. So this is called the coordinate plane. I'm not going to define it. You know what? Nope. This is the coordinate plane. Okay, this is the coordinate plane. This is where you graph the point. So we're going to go into all of that. So a point, let's say, oh my goodness, I gotta go here. You're with me. All right, so we have ordered pairs. Ordered pairs are points that are found on the coordinate plane, right? Your X relates to your domain. This is the X. This is the X axis. So the X axis of the coordinate plane. This is the Y axis. Now you will probably not have to graph these by hand, but you do need to have an understanding of all of this because you all are going to have access to graphing calculators. So that's not the issue. You just need to understand what all of this means. So, okay, cool. You have an X-axis. That's going to be your horizontal one. Your Y-axis. That's going to be your vertical one. Now, on the right of your coordinate plane are your positive values. So if you're going to the right, you're going to the positive values. On the left is your negative values. So if you're going that way, you're negative. And right here is the origin. So the origin is always 0, 0. So that we're going to always start at the origin. So when we're graphing points, when we're talking about points, so the X coordinate, X1 because that's the first coordinate, X1 is 0, Y1 is 0. That is going to be right dead center of this coordinate plane, okay? Now, the other thing, just with respect to positive, negative, is when you go up on the Y-axis. So your Y-axis is going to be vertical. Up is positive and down is negative, starting at 0, okay? So we're building our foundation on ordered pairs. We're building our foundation on how to graph ordered pairs. We're going to move all of that we're going to the creation of lines from ordered pairs. So we're going to go through slope, and we're going to go to at least y equals mx plus b. I plan for, I got to take this baby to work at 3, so I may not be able to go that far, and I may not be able to make it to parabolas, but I'm going to try. All right, so I'm going to keep it moving. All right, so we know our origin is at 0, 0. We know our x-axis is horizontal, and we know our y-axis is vertical. Now, how do we get to an ordered pair? So remember we said x right plus left negative, right? Okay, so you're going to look at the number, right? So let's say I gave myself an example, so I wouldn't have to do that. My example for the ordered pair is 3. I'm going to switch to positive 3 and negative 4 because I want to use our time wisely, okay? So this is the x value. So this is the first. So if I were to ask you what the x value is, it is my hope that you know that the x value of that ordered pair is 3. This is also called a point. So it's an ordered pair or a point. So just as far as the language that we use interchangeably, boom. Now, how would we graph that? So I'm gonna do this. So 1, 2, 3, 4. Again, you will probably not have to do this. You have access to graphing calculators and scientific calculators online. I do not have access to a projector right now, so I'm having to do all of this by hand. So nothing's gonna be exact, it's all an estimation. This is how I would teach it without the resources, so it is what it is. All right, cool. Notice this line ain't straight. It don't have to be perfect, you need to understand the concepts. All right, now, positive 3. We're gonna start at the origin, go x, meaning we're gonna go either left if the number's negative or right if the number's positive, okay? Now I'm gonna write that, I'm gonna move it because I like that. And I'm gonna put it in a different color. Because this is what happens. So as we look at the x value, if it's negative, we go left, or if it's positive, we go right. Okay, that's what you do with the x term. So I see a positive 3, so I'm gonna write 3, starting from the origin. So I start at the origin, and I go 1, 2, 3 units. I don't move my pencil, pen, or writing utensil because I've done the x coordinate move. Now I need to do the y coordinate move. My y coordinate is -4. So if I go up, that's gonna be positive, or down, negative. All right, let's go there. So this is how you graph a point. The first number, you're either gonna go left or right. The second number, you're either gonna go up or down. And if it's 0 or on either of those, then you don't move, okay? All right, but anyway, so we started here, we went to the right 3 because we had a positive 3. But now we have a -4. So we look, we know it's a negative, so that means I go down. Go down 1, 2, 3, 4. Put a point. So this is the point, positive 3, -4. And that's how you apply a point. This would be its x1 coordinate and its y1 coordinate. So these don't matter, that's just what I did to move, but that's the point at positive 3, -4. We okay? All right, oh, I'm sorry. This would be down 4. All right, so, good. Again, for the sake of time, no, I'll be honest, we gotta have a little bit of continuity with this. So I'm gonna hit you with a 6, 0, a -1, -2, -3, positive 4. Okay, I just want to for the sake of practice. I know that hopefully I'll be able to use this later, but boom. All right, so positive 6, meaning we would go to the right 6, start at the origin. Go to the right 6, 1, 2, 3, 4, 5, 6. 0 means that's where that point would be. So I'm gonna put a B there. That's where our B point would be, okay? So C point. So this would be, for those who come in or if you watch it, we went right 6 and then no move. Okay, because 0 means you don't go up or down, you don't go left or right. Wherever the 0 sits, don't move. All right, so here we got a -1, so I should know I go left 1. And I got -2, so I should go down, and you have to go in that order. So you have to do the x, then the y for these. That's important. Because we're gonna do slope and we're gonna do a different order. So anyway, so you have to go in that order. So the C point, start at 0, 0. Go left 1, go down 2, put the point, that's our C point. Now, D point, -3, 4, okay? We know it's a negative, so that means I go left 3. We know it's a positive, so left or right is the first one, up or down, so that means I go up 4, okay? Start at the origin. Start at the origin, go back to 0, 0. I go left 3, left 1, 2, 3. From there, I go up 4, 1, 2, 3, 4. If educators catch this video or on this video, a great way to teach this, because our students are very hands-on. And so sometimes this is a little too abstract. So if you like day 1-ish or day 1 of opening this unit, or after you've introduced coordinate plane ordered pairs, have your students like create your desk, like let's say your door's right here, create your desk like an ordered plane. like a coordinate plane, and actually give them a card with their seat on it. So whoever sits here, you know who sits here, because you in most cases, you've assigned your seats. So yeah, it would be like positive, but it's a practice of going up and then over, or up and then over, or down and then over. So it's just the process of how you, and then just give them coordinates. So this would be our 1-1, this would be our 1-2, this would be our 1-3. And so instead of your seat number is 14, this is how you get to your seat. Go left 1, up 2. You know what I'm saying? So that's a way to like have them actually walk the court. And no, it's not walk, but it's the process of this is how I would have to read it. And then maybe have their names on it from there, but something to identify they're in the right place so they know that they got to the right place or something to that nature. But just an exercise in actually doing the work. All right, and there's one more thing just for continuity for students. So you know if you're in the right place. Quadrants. You do have to number the quadrants. The numbers for the quadrants are numbered in a C. So 1, 2, 3, 4. So if you're ever asked about the quadrants, remember they're numbered in a C. If you draw a C in the coordinate plane, 1, 2, 3, 4. All the ordered pairs would be positive. Here, all of the ordered pairs are going to be negative, positive, if they're in the coordinate plane. On the line is different. Here, you're going to have negative, and here, you're going to have positive, negative. So just a couple of things that you can take with you as far as there have been times I've seen test questions with which quadrant is this point located in? And there are also, if you know that everything here is positive, then I know there's no way C will be there. That makes sense? So if I know everything is here is positive, D won't be there. So I kind of have an idea of where a point cannot be because I know what the points are in that quadrant. All right, so next, order pairs and graphing, check. Slope. All right, slope. Now, we just talked about order pairs, right? I do have order pairs. Slope. Those of you, if I catch any other First of all, upperclassmen, yes, because this is the same thing as average rate of change. So lower levels is going to be slope. Not lower levels bad, lower levels 8th, 9th grade. Upper levels, and truthfully, we did average rate of change in AROC is what I would call it. We did it in the 9th grade. It was a hard concept, but again, children, slope. Average rate of change, same thing. Slope. If you can find slope, you can find the average rate of change. So upperclassmen, slope. If you could find slope, you can find average rate of change. It's just a different formula, but it's the exact same thing. And the process is, I'm a math major, so it's the change in the symbol is a diamond. The change in Y divided by the change in X. So simplified for me is change in Y over change in X. For you all, and again, I know that I might catch some people who just want to clear up some understanding and they'll be like, yo, I'm really good at math, but there's some things I don't understand, but I can watch your videos real quick and it clears some understanding, so that's why that's there. So if you ever see that, that's all that means, the difference in it. Okay, so that's going to be Y minus Y divided by X minus X. Now the reason why I wrote it that way, because that's not the formula. The formula is, so for real, the formula is Y sub 2 minus Y sub 1. Oh, I'm sorry, let me hit you with the all the way. M equals, so M equals Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. The reason why I put Y minus Y over X minus X is, if you stay consistent, it doesn't matter which point you start with. So let me show you. All right. What you can't do is switch up points. So I'm going to work it in blue. So our our 2 points, find and slope, are going to be, and then I'm gonna say, I'm gonna take all of this, because time is of the essence, and I'm gonna go straight into creating the line. So here we go. So our 2 points are 3, 2, and 6, negative 4. All right, cool. All right, so what we're going to do, here's what Miss Logan does, okay? So what Miss Logan does is, because Miss Logan has moments. So we're going to first use the equation as is. So as is. Okay? Use the equation as is. If we use the equation as is, the first thing we're going to do is label the points. 1, label points. X1, Y1, X2, Y2. Remember, every coordinate pair is going to be XY. The 1 represents the first coordinate pair. The 2 represents the second coordinate pair. It just lets you know what's what. All right, once you've labeled the points, you're going to substitute into the equation. All right, so we have M equals Y2 minus Y1 over X2 minus X1, correct? So if I go to my ordered pairs, I know that Y2, okay, so here we go. Boom, Y2 minus Y1, X2 minus X1. I do this with teaching because when I do that, something has to go there. So we know we got to put something there, right? All right, so what is the Y2? I'll go up here, my Y2 is negative 4, all right? Negative 4. What is the Y1? It is positive 2, all right? X2. X2 is 6, and X1 is 3. All right, cool. So we have now substituted in the values we need. All right? Now, we simplify. Now, if you're not good at math, and you're not good at the numbers, it's okay. This is when you pick up a calculator. You're going to put negative 4 minus 2 in the calculator, and the calculator understands the order of operations as long as you tell it what to do. So it's not more powerful than your brain because you have to tell it what to do. So you have to tell it the right thing to do. Then it can do the right thing. But if you tell it the wrong thing to do, then it's going to give you the wrong answer. So it's not more powerful than you. It's just a powerful tool. So you do need the calculator. You need to know how to work it. So in the calculator, you would put negative 4 minus 2. You will then get negative 6. And I'm saying do them separately so you can actually make sure the numerator is what it's supposed to be, because sometimes the sign matters. All right, and then 6 minus 3 is 2. Cool. That's wonderful, except we're not done. So M equals negative 6 over 2. We know that a negative divided by a negative is a negative, and 6 divided by 2 is 3. So the slope here is positive 3. All right, so we did it the way it was supposed to be done. Right? We put the second with the second first. Now we're going to do first point first. Okay? Now, we're doing this because I want you to see that it doesn't matter which point you choose with. You just can't do y2 minus y1, then x1 minus x2. That's where you'll mess something up. So if I start with the second point, the way the equation says, I'm going to get the right answer. But let's say I start with the first point because I forgot, but I do know that it's y minus y over x minus x. Okay, cool. Let's go. So M equals y minus y over x minus x. But I forgot which one to start with. I just know I got to start with the point. All right, so M equals, well, we go ahead and get our containers ready, right? We know something has to be there. Well, I forgot, but I know I have to do y over x. So I'm going to do 2 minus negative 4, okay? So 2 minus negative 4. Then I have to do, as long as I do 3 minus 6, everything's going to work out all right. So then I do 3 minus 6. Okay, let's go. So M equals 2 minus negative 4 turns into, because we know that turns into plus. A negative times a negative is a positive. And then the denominator is just 3 minus 6. I'm sorry, 3. So then we have 6 over, did I make a mistake? Yes, oh my God, I made a mistake. I'm sorry, y'all. Oh, I'm sorry, y'all, I made a mistake in the math. Here, this should not be a 2. I hope somebody is out there like, Miss Logan, you made a mistake. Ooh, 6 minus 3 is 3. That should be 3, and then that's negative 2. Fix that. All right, sorry, y'all. I made a mistake. I had to go correct it. I subtracted wrong. I did 6. I subtracted wrong. Okay, so 6, that's 2, negative 2. That's the correct answer because when I got over here, I knew I was about to have the incorrect answer. Because 6 divided by negative 3 equals negative 2. So if you notice, it doesn't matter which way you do it. You're going to get the right answer. Just make sure that you be consistent. So if you start with the second point, continue to start with the second point. If you start with the first point, continue to start with the first point. You will get there. All right. Now we have found the slope. So we know that the slope of these 2 points, m equals 2. I'm not going backwards because I've been going since 10. So I'm going to keep moving. All right. So we know how to find slope now. Cool. Now, how do we find the equation of a line? Because that is a really huge component in algebra and geometry. Both, actually. Because it just is. It just is. All right, cool. Oh, actually, we're not moving too far. We're not moving too bad because all right, so we're going to start with, so this is, we're using the same point so that I don't have to double back. And we're going to do, how do I find the equation of the line? How do I find the equation of a line? All right, cool. So this is going to be point slope version, okay? Because there's a way where if I know the point slope, for those of you who know, point slope is y equals mx plus b. For those of you who don't know, the point slope formula is y equals mx plus b. Y, no, m. So m here is the slope. And b here is the y-intercept. Ooh, I jumped off this bridge without the y-intercept. Oh, it's too late. All right, this happens. All right, so I jumped off this bridge without the y-intercept, and I said we were going to do this point slope, so we have to do this the hard way. Oh, why did I do that to myself? That's okay. Okay, so what happens here, because if I'm being honest, you might see problems like this. So as much as I'm not happy with me doing it the hard way, you might see a problem like this. Because what happens when I do have the slope, or I only have 2 points, and I need to find the equation, and neither one of them is the point slope. Now, what you can do just as a cheat code, because I love you. You know what I'm saying? Why? Cheat code. And it's not a cheat code. It's just another way to solve it. It's just an easy method. Graph it. And identify the necessary information. Just 1 second. When I am able to project, then I will actually show you what I'm talking about. But for those of you who know Desmos, and if any educators catch this, then hey, this is a great, because they need to know how to use Desmos. It is such a strong tool when you know how to use it, especially with quadratics and exponentials. Like we do, 9th grade math does a lot of work in exponentials, does a lot of work in the quadratics, and the graphing component helps with students to be able to see what's happening with the components, which is why I want to get to parabolas, which is why I'm moving quickly. Anyway, so we're going to go ahead and go. We don't have the point. We're going to find it. We're going to find it. Or it doesn't exist. We'll see when we get there. I don't know because I didn't actually work this out. All right, so what you have to do in a situation like this is first find slope. We've already done that. Second, if B exists, which right now it doesn't, use y equals mx plus b. To create the equation. Okay, but that doesn't happen, all right? So we have to, as a caveat to our B, is we have to use a point, substitute into the equation to find B. So that's what we have to do. Because I didn't actually give you a, I didn't think about it. I planned this at like 5 a.m. So it's as far as the problem set. So I didn't think about it. So this is good. All right, because what that means is we already have an x1, y1. That's what this becomes. Let me hit you with the black. So this is where you do that. So we don't have our b. We're going to find our b. And then I'll come back and show it that way. So we have to find b. All right, we got to find b. I don't want to, but that's what we got to do. So we're going to substitute everything into the equation. Use a point, substitute into the equation with the slope. All right, so I know m equals 2. I know my point is x1, y1, 3, 2. So I take this, mx plus b. I substitute in everything I know. I know y1, I know the slope, I know x1, I do not know b. Okay? y1 is 2. x1 is 3. The m is 2. Okay? Third, simplify. Okay? So 2 is equal to 2. And then 6 plus b. Now, remember we started with single step equations. Here's why. Because in everything, all of those things come back to needing to be used. So we've got to, and that's I'm sorry, my 6's and my b's do look alike. So here, we're going to simplify to find b. So first we just simplified so that we could get something that we could work with. Now we need to simplify to find b, and we need to solve the equation. So all that we learned in equation solving, it comes back here. And it's usually going to be single step, but if it's not, do what you got to do. All right, so we see, we see plus, use, minus. So I see plus 6. Now, don't move your variable. Well, you can, but it's not necessarily helpful. Because you'll just be doing back and forth, because the goal is to get b by itself. So if I move the 6 away from the b, then I'll have the answer. So then b equals, and 2 minus 6 is negative 4. So you made sure to subtract 6 from each side. So we solve plus 6, we're going to minus 6, we do that to each side, and then we simplify again. Now, this is good for SAT, ACT too. You'll see a lot of this. Because so now I have b. So the 6th thing, which is why this was the harder, use m and b to write the equation. All right, so now that we've done that, I'm gonna come with a different color. Oh, no, I'm not. No, I'm not. I'm gonna hit you with the green. All right, so now we go back to y equals mx plus b. Because what we did was we used 1 point on the line to find the y-intercept. Now we need to write the equation of the line that represents every point on the line, and that's what we're doing. So that's why you only use that x and y when you're trying to find something that you don't have. So if you have the b and the x and y, you can find the slope type situation. But when you're looking for the general, then you're gonna keep the y, you're gonna substitute the x and the b. So we know, so the goal is to find the m and b. So we found the m is 2. Let me hit you with a different color. B is, and I love that it's negative 4, yes, because we got to deal with the double negative. Deal with the subtraction. So what we have now is y equals 2x plus negative 4. We've already discussed it that you will not leave it in that form. You will change that to y equals 2x minus 4. Okay, so that's your final answer. Now, if we had, so let's say, because we might as well go here. So let's say you had, so instead of this, we knew m equals 2, and we know that b equals negative 4. We can go directly to y equals mx plus b. So there will be some problems where they give you the point and they give you the slope. They give you the y-intercept. So that is the y-intercept, and that looks so much like that looks so much like a 6. I'm gonna change it. This is the y-intercept. That's also a b. So when you see that, aka b, y-intercept, if they give you that, all you gotta do is go straight to the equation. Y equals, substitute in m, substitute in the b. Y equals 2x. We put in a negative 4. Let's go. So, super quick when you know the y-intercept and the slope. Not as quick when you don't, but in either case you can get there. Now, we're going to do one more round with this because there is one more thing that they do ask you as individuals who, you know, sitting in algebra. Yo, I'm out of practice. That was not point slope. That was not point slope. That was slope intercept. I bet there is a math person out there screaming at me. That was slope intercept form. I did all of that. I'm so sorry. It's live, so there's nothing I can do about it. But yeah, that was now we're gonna do point slope. So I'm X. I want you to know I made a mistake. Boom, that was complete. All the math was correct. I just gave you the wrong term because I'm not actually looking at my books and stuff. That was the slope intercept. Slope y-intercept. That's why it's called slope intercept. So slope intercept, for clarity, y equals mx plus b. That's what we just did. Point slope is y minus y1 equals m times x minus x1. My apologies. That was wrong. All right, so slope intercept, that's what we did first. Okay, so if you're at this point and you haven't been here, number one, I'm doing a fundraiser. I'm in hour number 3-ish, maybe 4. I'm building a math channel for all students and definitely with my students from Title I schools and non-traditional schools in mind, and I am hopefully going to get some funds to help me continue to create. If not, the channel's going to pay for itself, at which point students, you know, actually check in because they want to learn, because some students really want to learn. I'm not the only hyperactive person in this world. Anyway, so I just needed to make a correction. So if you just got here, I've been building a whole bunch of stuff for algebra and geometry, and we're at the point where we're graphing. And I made a mistake, and I just want to be clear that we just did slope intercept form, y equals mx plus b. We are now moving into point slope form. So I said it was point slope, and that was not what we were working with. So now I'm going to not cross that out. This is point slope. And the equation for point slope is the equation that actually has the slope and you need a point. Like duh, Terry. Anyway. I told y'all in the beginning, I'm out of practice. It's been 2 years. Forgive me. I'm sorry. So with this, if you don't have the slope, and we already did that, the first, like if you're given 2 points, step 1 is find slope. So step 1, find slope. We don't have to find slope because we are working with the same points for the sake of time, and I'm not going back. So we already found the slope. Our slope is 2. All right. From there, the next step, use 1 point, it doesn't matter which, to find the equation. Now, the good thing about this method is you go straight to the equation. So we know our slope, so this is when we come, and I'm going to start from the beginning, meaning I'm going to rewrite the equation. Because that's just, I'm a little OCD that way. I'm going to give you parentheses for where we need to put information in. So this is going to stay the same. I got to put something right here. I got to put something right here. The X is going to stay the same. I'm going to put something right there. Okay? I'm going to change colors. All right. So Y1, we know it's a 2. We labeled it. Our slope, M, we know it's a 2. We calculated it. And X1 is a 3. We labeled it. So I know it seems very tedious and it seems like a lot, but when you put something there, something got to go in it. What's got to go in it? So your brain goes, well, what am I supposed to put right there? Well, at least that's what my brain does. And if you're with me, then I'm going to kind of condition. This is how I'm going to think out loud. This is how we work this. All right, now simplify. Simplify. So I have y minus 2 equals 2 times x minus 3. Now that's as simple. You want to write it in a way so now I know what to do. So if you've been with me, first of all, even if you ain't been with me, we got to figure out what we want to do first. I would simplify this. So I would go back to, I would err to PEMDAS. order of operations, I would take care of that parentheses, so I would distribute 2. Don't want to make any fractions, so I wouldn't divide it out. And we don't want to move this yet, because then we got to deal with funky numbers, and we don't want to do that. So I would distribute the 2 to everything in the parentheses on this side. That's what I would do. So that's going to, and then that's going to take you to a process to simplify, right? So y minus 2 equals 2 times x plus 2 times negative 3. And I just want to make sure that we keep our sign, so that's why we're doing that. All right. Simplify. That's what I said. So y minus 2 equals 2x plus negative 6. Y minus 2 equals 2x minus 6. Perfect. Except we're not done. We are in a wonderful place. We're in a wonderful place. Wonderful place. But we're not finished yet. So what we want to do is we've simplified step 5. Once we want to do that, this is going to be a process similar to combining like terms, but we're really solving for y. But we're going to use, I'm going to say combining like terms, combining, because we have to get everything, solving for everything here that's alike we got to get everything away from the y, positive 1 in front of the y, and we have to combine what's alike. So I've only done one x value, and I've got these 2 values that don't have an x, but they're on opposite sides of the equation, okay? So that means I gotta figure out how to get that 2 over there. So this is when I go through the solving equation process. What do I see? I see subtraction. C minus, use plus. All right, cool. So I see subtraction, minus 2. Then that means I know I need to plus 2 to each side, okay? So I'm going to plus 2 to each side of the equation. So this, again, this is why this line is necessary, and why we talked about combining like terms, because I'm not going to put the 2 here, because in order to add something to that, it needs to have an x. So the positive 2 has to go over here with the other thing that it's alike, right? That goes to 0. And then we combine the negative 6 and the 4. Okay? I mean the negative 6 and the 2. I think money, positive, negative. So you were in the hole $6, you got $2, you're still in the hole 4. So we got to think of positive and negative that way, because we want to make sure to keep our signs, because again, the signs is what gets you every time. Boom. That's the equation of the line, and we're done. So it's a seemingly a long process, but it takes you directly to the equation of the line. So it's one of those things where I don't have to go back and substitute and once I'm done, I'm done. So that's why I do like it, but you do have to remember it. And if I'm not mistaken, actually, I don't know. I think South Carolina gives you this equation. I know they give you y equals mx plus b, and I think they give you points, so I'm not 100% positive. All right, so, okay, wait. If I have done that, and it is 2, can I do parabolas in 30 minutes? Wait a minute, Jesus. Wait a minute. Okay, so I'm gonna go for one more, y'all. We're gonna go for parabolas. Because the last time I taught 9th grade, this was in the 9th grade curriculum. And it bothered my soul, but it is what it is. So we're just I'm gonna run through this, not super fast. But I want to talk about the quadratic function for a minute. And this is it. Yeah, this is necessary. So since I'm at 2 o'clock and I can get this done in 30 minutes or less, I'm going to keep pushing. Because I think it's important. And again, the last time I taught, this was in the 9th grade curriculum. I'm not sure where it is right now. But if it is still there, then there's a level of something needs to be out there to kind of just talk about it. And like I told you, Victor kind of made some things easy that I feel like if I go through it, then it'll be easier for some individuals to understand as they're learning. So parabola looks like a U. All right, so again, if you notice, if you've been here, I know at least one person's been here the whole time. I talked about Victor. So Victor, my boys were hilarious. There were 3 of them. And again, they ended up just performing so well, I had to just give them other ways to just kind of pace them so I wasn't teaching 2 courses at the same time. Like I will be doing right now. Algorithm. Anyway, but Victor, this is a U, right? Relatively. It's not perfect. It's not going to, like, our U is going to have equal sides. We'll talk about it in a second, but this is a U. So if you think about this from the perspective of a U, then this U can be flipped upside down and right side up. And that's going to help us when it comes to thinking about what's what. So this is the U. So the whole time I'm going to be talking to you. And that's the Y. All right, cool. So we know that the parabola or the quadratic function looks like a U. So I'm about to hit you with a random graph. All right, I'm going to load it up. This is the Y. This is the X. Because I don't want to do the parent, and I actually want to talk about some features, then I'm not going to do the parent function. All right. All right. I want okay, bear with me. I didn't do this before. Okay. All right, let's go. All right, that's better. Good. All right, like that. All right, let's go. All right, so we're gonna go a lot of places. Now this is for the equation y equals ax squared plus bx plus c. That is also known as the quadratic function, okay? All right, so also known as y equals x squared. So this is going to be our parent function. Now, we're not going to talk about that in detail, but it will come in handy later. So that's the one that starts at 0, 0. So that's what's important for you, the vertex. Now, I said something. What does vertex mean? So your vertex of a parabola. So what we're doing is we're investigating the features, because that's where we begin, or at least that's where we began. So that's why I'm putting it out here. And I kind of looked around and I feel like I saw it, so I'm putting it out here so we have something here. That's the bottom line. So your vertex. So features meaning what's the equation? Vertex, that's one of the features. Now, remember I said that U, boom. Your vertex is going to be either the lowest point, minimum, or the highest point, maximum. Okay? So I meant to bring a bold, but it's okay. If we keep this in mind, this is always with you. You'll be in the test and you can hit, because Victor would do that. He came, that was what he came up with. And he would be in the test and be like, Ms. Logan, is this a max or is this a max? I can't answer that question. Victor, that's the answer. And you're going to tell everybody else if I answer. But it was just a wonderful way to think about it. So minimum, lowest point. Maximum, highest point. Okay? So your vertex is that point. So we're going to figure out what it is. And then as we build, we're going to do that. So for the parent, the vertex is always going to sit at 0. And for the sake of argument, the parent function is going to look like a U. Coming out of the origin. So everything that doesn't is not at 0, 0, is a transformation of the parent. So we're not dealing with transformations right now, but just know that this parent function without any of this other stuff is going to be at 0, 0. Now, if it has that stuff, then that's what we're talking about. Now, those have features, and we'll talk about that because I am going to do parent functions, but I'm going to do them as a unit, so to speak. So there are 6 parent functions, and I'm going to do them all. And I'm going to do one video with all of them. And when we do that, by the time we hit the 6th one, you'll be able to find domain, range, intervals of increase, intervals of decrease. What else do you need to know? Roots. We'll get there. Anyway, but I'm going to do that separately, not today. Because it's 2:06 and I got 20 minutes and I'm about to be done, baby. Anyway, all right, so we got the equation. We got the vertex. We don't know what the vertex is, so our vertex, that's going to be the point where the graph changes for us. So just mathematically, remember I talked about points of increase, decrease. This is the point where the graph changes. So if it's upside down, there's a point, highest point or lowest point. So this is the vertex for a upward facing parabola. So up, A is positive. So your U will look like that. That has a minimum. So this has a vertex. The vertex is the minimum because it is the lowest point. So I'm also going to put that. Okay, so lowest point, minimum. All right, down. Vertex, max, that's going to be your highest point. So that's when your hand is down, right? You got that U, highest point. There's a point that's the top of your hand, right? So that is when the A is negative. You don't know what that means. All right, hold on. So that's a maximum, and that's the highest point. All right, now what do I mean by A is negative? Because the reason I said that, oh, right here, well, I'm sorry, I just didn't talk about it. So in the equation, let's say you have y equals 2x squared and y equals negative 1/2 x squared. This one's going to be facing up because A is positive. And this one, A equals negative, is going to be facing down. So that's what I mean. So it's the leading coefficient. Even if it's just negative x squared and it's not like negative 3x squared. If the leading coefficient is negative, it's facing down. If the leading coefficient is positive, it's facing up. So there are some things that you don't have to know everything about the equation, then you'll be able to find some things. Because it's like, oh, if it's negative, it's down. So, okay, I don't know everything else, but I can tell, like, pictorially, if I got 2 of them facing up, those 2 can't be the answer. So I can at least now got a 50% chance of getting the answer right. Does that make sense? So know some of the stuff. And another wonderful tool, graphing. Because when you graph it, if you put your equation in, now I have to erase because I'm running out of space, but if you put your equation into decimals.com, then you can begin to just identify the features. Okay? This looks a little cumbersome. And since I'm building something big, then it is what it is. All right, let's go to the next thing, which is the axis of symmetry. So we have the axis of symmetry. This is just a line of symmetry. And it cuts the graph in half. So I want you to think of a line of symmetry as your body has one. So no, if we're like exact, our left and our right side of our body are not exactly matched. But for all intents and purposes, the left and the right are mirrors of each other. So that's what we want to think. The axis of symmetry cuts your graph in half. So each, whether it's facing up or down, you're going to have an axis of symmetry. And it's going to cut your graph in half. So that line is the axis of symmetry. So We did problem sets prior to that. This would be more of a lesson because right now I just got to teach it to you. You know what I'm saying? Like I can't be like, oh, let's do it. No, like this is heavy, and I gotta go through it. All right. So axis of symmetry. Now the equation is x equals whatever the x coordinate of the vertex. All right. Now I intentionally left off finding the vertex of this parabola. So we know where the vertex is. We know that this parabola has a vertex of that is a minimum. We don't know what the vertex actually is. So the vertex is actually found at, we're going to start at 0, 0, go to the right, 1, 2, 3, 4. So positive 4. And then from there we go down 1, 2, 3, negative 3. So our x coordinate is positive 4. Our y coordinate is negative 3. So for the axis of symmetry, x equals 4. If you have the vertex, you have the equation for the axis of symmetry. Now, there is another way. Nope, we're not going to talk about the other way. I'm lying. For exceptional, if you got it, I'm going to put it here because I didn't actually give you an equation. There is another way to calculate it. It's the opposite of b over 2a. Okay? So this is from the a, b, and c here. So if you have an equation, I'm just going to... Sorry, y'all. I know y'all doing it. Okay. So let's say you have an equation and it is y equals what I need, opposite of b over 2a. 3x squared minus 18x plus 4. Come on, man. No. All right, so for those of you who are cool with this process, what you would do is identify your A, B, and C. A, B, C. A equals 3. B equals negative 18. C equals 4. You don't need the C yet, but that's just so you can identify it. To find the x coordinate, you would do x equals the opposite. Leave that, negative 18, that's your b, over 2 times your a is 3, right? So the opposite of negative 18 is positive 18 divided by 6, and that's 3. Oh, wait. Did I just make another mistake? Jesus. 2a. Wait, did I make a mistake here? I need my book. Sorry, y'all. You know what? H comma K. Nope. Let's just take this off the table for the time being. I'll come back. I'm pretty sure I'm right, but I don't wanna get lost in the sauce. It's too late, and they out cutting grass. Don't worry about it. I know that that's right. Because it's H comma K and X equals H. So I know I'm right. So as far as axis of symmetry, we're not going to go with calculations right now because I don't have that information in front of me and I do not want to teach you wrong. So no deviation. Let's go back to the next feature. So we talked about the vertex. We talked about the axis of symmetry. We have not talked about roots or zeros. All right. So there's one more thing. This is best found from the graph. You can find it algebraically. We're not going to talk about that today. So roots. This is AKA solutions, zeros, or x-intercepts. They all mean the same thing. They all mean, these all mean the points where your graph cross the x-axis. Okay? X. Okay. So for us, we're going to go back to the main one because that's what I did it for. There are 2 points. Boom. Boom. Those are your zeros. Now, some solutions. Wait, stop. So let's first identify it. So x-axis only. So the first x is positive 2. And so 1, 2, 3, 4, 5, 6, positive 6. So you could write your x's that way. Or you could write them as ordered pairs. And so this we didn't talk about, well, we did, but we didn't actually do it. So we would go start at 0, 0, left to right first, positive 2. And then we would not go up to no move, so we would do 0. And then 6, 0. So your zeros, roots, solutions, x-intercepts will always be a number and a 0. They will always be in that format. So this one has 2 roots. Now, for the sake of argument, this one has no roots because it does not cross the x-axis. And then the parent function, which I'm going to put in blue, has 1 root. So those are your 3 examples as far as your root solution situation. You've got 1 where the graph is sitting on the x-axis. So that's the only time it crosses the x-axis. You have 2 where the vertex is below the x-axis, so the arms cross the x-axis twice. And then you have the third situation where it's facing down and the vertex is below the x-axis, so it does not cross the x-axis at all. This is imaginary solutions. We won't go there, but these are the scenarios. And again, this helps you when it comes to answer choice, because if I know it doesn't cross the x-axis, it don't have no zeros. If I know it crosses twice, it has 2 zeros. If I know it's sitting on the line, it has 1 0. When you're dealing with quadratics, especially in Algebra 2, that becomes important when you're actually trying to find out what those values are, especially if you're using the quadratic function. All right, we talked about up and down, we talked about x-intercepts. We have not talked about y-intercept. So we did talk about x-intercept, and that is where your graph crosses the x-axis. So then that leads to the y-intercept. And this is where your graph crosses the y-axis. Okay, so, and again, not all of them will, but they might. And if they do, you find that point. And most of the time, it's 1 point and not 2. So for your y-intercept, where's the top? For your y-intercept, and we've been dealing with just the black graph for the most part. We've been kind of looking at them both, but that's the one where I specifically made sure to put those things on there. For your y-intercept, if you look, the black graph crosses at, we start at 0, 0, no left, right, just go up 1, 2, 3. It crosses at 0, positive 3. So that's the y-intercept, which remember we did slope-intercept form and point slope. That's going to be your B. That's what that letter stands for. Lowercase b is slope. I mean y-intercept. Now, so for the blue one, b equals 0. B equals 0. And for the upside down one, 1, 2, 3, 4, 5. B would probably be negative 6. Okay? So we just want to make sure that we're able to find it. We know what it means. All right, I do have a little bit more. Let's talk about domain and range. Now, because I only want to talk about one of them, I'm taking the blue off. Yep. Take the blue off. And I'm going to take the upside down one off, okay? Because I just want to focus. I don't want to spend a whole bunch of time. I know we in this is a different level of instruction. I've been working problems, and now I'm actually like giving you meat. All right, so we've talked about, we have 2 more features to talk about. Domain range. Domain and range is important. Again, parent functions. They're going to ask you domain and range. I'm not going to get into function notation. We're just going to talk about what it is. Well, I'm not going to spend a whole bunch of time on that. So the domain is a set of x values. We'll talk about what that represents for this chart, but I just want to talk about, like, define, that's all the x values. So when you're dealing with continuous functions, these are going to be represented in set notation in a way. We'll talk about that specifically later. I'm going to keep it pushing. So the domain. If I take my pencil, I don't have a mark. So let's say I take my pencil across. If there's anywhere, so to speak. Now, the arrows implies that it continues in those directions, right? Okay. So if I were to take my line, would there be any place that hypothetically speaking, the parabola would not hit the x-axis? No. There's going to be a picture everywhere for the x. Because even if my x is all the way out there, the arms go up. So somewhere it's going to touch the parabola. So from left to right, for the parabola, it's all real numbers. That's going to be the symbol for me for all real. That's the symbol for all real. That's what I'm going to use. All right, so from left to right. Oh, and let me do that. From left to right. So that's where we're looking. You're looking from left to right. Is there a picture? Is there a picture? Is there a picture? Meaning, could I find, if I went to 1,000 in the positive direction, could I go somewhere and get a picture? Yeah. If I went to 1,000 in the negative direction, could I go somewhere and get a picture? Yes. Now, I would have to go up to get the picture, which is why the range is a little different. And as far as a set notation, you might see the set of x values. X is greater than, no. I feel like you'll see, you might see negative infinity, negative infinity to positive infinity. You might see that. I feel like this is open. If that's open, then you would see that. Closed is inclusive, if I'm not mistaken. So open is non-inclusive. I'm just trying to think of answer choices so you'll know what to choose. Because it may not say all real numbers and it may not have that symbol. It may have something like that. This means all real numbers because that means you can go as far left to negative infinity, you will get an output, and you will. And you can go as far right to positive infinity, and you'll get an output, and you will. So that's that. Now range. Range is totally different. Range is totally different. Because there is a place where we don't have a picture. There is nothing of output here. So there is a lowest point. So that's where the minimum or the maximum come in handy because my y values, so this is the set of y values. Set of y values. I gotta hurry up. Set of y values. So this is so up and down. Your thought is there a lowest point or highest point? If so, that means there is someplace there is no output, that there is someplace that the domain is restricted. So for our domain, our y values are going to start at -3. So y is greater than or equal to -3. Now it is equal to because our line is solid. When we're dealing with inequalities, if the line is dotted, then we would not include that because that means that the actual points that fall on the parabola are non-inclusive to the solution. That's not what we're talking about, but because we are using set notation and you will see set notation, then you need to make sure you have an understanding. Another way you could see -3 is less than equal to y less than equal to infinity. Let me see. So y is greater than -3, that's true. If the line is solid, it's equal to -3, true. And y is less than infinity. That might be true. But I don't want to sit on it because I didn't look at that. So I know we're good with y is greater than -3. So we're gonna stay, oh no, shoot. Okay, it's fine. What were the roots, 2 and 6? Let me do it again. 4 -3, and then 2, 4, 5, 6, 2 and 6. All right, rough sketch because we need one more thing and then we're done. And then I thank you so much. I'm gonna thank you in advance again. If you can help, thank you. If not, appreciate you for joining me, actually. And if all you can do is share, thank you. If you choose not to share, I understand. I thank you for staying with me this long, but please share with teachers and children because that's what I'm building for. I'm building to help clear up the things that are unclear in the math curriculum. Now we have intervals of increase or decrease. Okay, so that's the last thing. Now, with me laying this groundwork, I'm going to do the same thing for the parent function, and that's why we did not do them today. Because all of these things in the algebraic curriculum, the expectation is you know how to just, hey, it increases on this, it decreases on this, the roots are this. There is an expectation that you can recall this information really quickly. Now, what we need to know is the vertex. So I'm going to assume that 4, -3 is the correct value from before. I'm going to go with it. That's our vertex. Intervals of increase. So your intervals of increase, interval of increase with respect to x. Where does the graph go up? All right, that makes a difference because the reason why I said with respect to x, because that means we are looking left to right. Okay, so we're going to start here. And if we notice, looking left to right, here, the graph is falling. So it decreases up into this point. From here, the graph is rising. So the interval of increase starts at +4. And it continues until, so increase, as of right now, we're just going to do inequalities. Our x is greater than 4. Is it equal to 4? I'm going to say it's greater than 4 because 4 is where it turns. If I'm wrong, I'll come back and correct. So it's either greater than or greater than or equal to, but it's all of the x values that are at 4 or larger. So I think larger than 4 because, again, the vertex is the point where it turns. So the vertex is where it goes from falling to rising or from rising to falling. So this is your middle point, so to speak. That's the point of turn. So it starts at 4. So that's the interval of increase. Where does it go up? So then the interval of decrease, okay, decrease. So with respect to x, where does the graph go down or fall? And we want to consider this one a rise also. So I just want to keep the language. So we're looking at the graph, still looking for left to right. So from -infinity, so we can also do, you can do this. Is it closed? I think you can do 4 to infinity. Again, I'm going to come back because this one would be x is less than 4 or -infinity to 4. Because again, everything is with respect to x and everything is going to be left to right. So as I come from -infinity, the graph continues to fall until I get to 4. Then at 4 until so -infinity to 4. So we would do that this way. That's where we decrease. And then from 4 to +infinity, we increase. Okay? Now that is applicable with your absolute value function as far as domain, integrals, like all of this for the parent function is totally applicable. But that's all I wanted to cover today, and I'm tired and I'm hungry. But thank you for joining me. And please share because I'm probably gonna have to do all of this again because I may not be able to download this video. So thank you for joining me. Appreciate you so much. Please spread the word. I'm gonna get the curriculum. I mean, I have the curriculum. I just need somebody to feed me the standards to make it easier. So all I got to do is produce the videos instead of having to figure out the curriculum and the scope and sequence. So I know the state has a scope and sequence guide and I've looked at it, but I just need, I would prefer a teacher who is planning right now to just send me your first 2 weeks so I can. So I've talked to a friend, I believe it's coming, and today I'm gonna chill because
The T-shirt marathon is over. Thank you so much for joining me, and please, please, please share with students who you think might gain value from learning from me. I would really greatly appreciate that. And if you can help, thank you. And if not, appreciate you for joining me. Have a blessed day.